Hello everybody and welcome to a brand new tutorial series on this channel where I will be showing you how to make a car racing game in Python using pygame. Now pygame is one of my favorite modules in Python. It's been a while since I've done a tutorial series using it, so I kind of came up with this game right here, which actually, fun fact, is one of the first games I ever created using a software called Game Maker. So I kind of recreated it in Python, and it turns out to actually be pretty complicated to implement and makes a really good tutorial. Anyways, let me explain who this tutorial is for, and then I will demo the game to you. So this tutorial is kind of designed for intermediate programmers. If you are a beginner, you can definitely follow along. I'll try my best to explain everything as always, but this is going to use quite a bit of kind of more advanced Python syntax or more intermediate Python syntax. And so if you haven't seen object-oriented programming before, it might be a little bit difficult to follow along, but again, I will try my best to explain. With that said, this will probably be 5 videos, maybe 2.5 hours of content. Everything you need will be linked in the description in each video. All of the assets you see here, most of them I actually made myself, and of course they're free to download from the description. All of the code that I write in each video will be uploaded to GitHub, so you can look at the code per video, not just the finished code. And yeah, with that said, that's pretty much everything you need to know. So let me demo the game for you, and then we will start actually writing the code. So the idea behind this game is we have 2 cars. One car is kind of the player car, so the red car. The other one is the computer, right? So the green car. Now the objective is to simply beat the green car to the finish line at every single level. Now you can see right now that the green car is going quite slow, but as the levels increase, it increases in speed and it gets progressively more difficult. Now I always like to leave my games pretty basic and then allow you guys to kind of add on to them. So something you could do to make this more challenging is add obstacles. You could add, like, I don't know, oil or something on the track so that you would slip if you hit it. You can do all kinds of crazy stuff. What I'll be showing you in this tutorial will allow you to kind of add that stuff as you continue. Now you can see here we moved on to level 2. Notice the car will get progressively faster, and then this game goes up to 10 levels. The last level has the green car almost as fast as the red car, and so if you beat that last level there, then you win the game. Anyways, I won't keep playing through this, but this is a pretty complicated thing to actually make. I know it looks trivial, but to allow the car to move in this way, to have this car follow a path, to have a collision with a track that's kind of not square, right? Not rectangular collision, to have the finish line, to increment levels, to change speeds. There's a lot going on here, and this is a really good kind of learning experience from this tutorial. Anyways, enough of this long introduction. I apologize. Let's go ahead and get into the code. All right, so let's go ahead and get started. Now we have some setup steps that we need to walk through. And then once we do that in this first video, I'm going to show you how we can move a car around the screen. I know that seems trivial, but we're going to implement acceleration, velocity, braking, and slowing down, and a bunch of other stuff like actually changing the angle of the car and determining the horizontal and vertical displacement of the car based on its angle. So it's actually pretty complicated, and that's why this video will be, the length it is. It's probably pretty long, although I haven't filmed it yet, obviously. And anyways, before we can do all that, we need to set up our environment. So I'm here in Visual Studio Code. Feel free to use whatever editor you want. And the first thing we're going to want to do here is download all of the assets for the game. So I'll just walk through them kind of one by one because I actually made almost all these assets myself. So hopefully you guys are impressed by that. But we have a finish line. We have this grass, which is kind of the background. I didn't make this. I found this on Google Images. We have a green car. I made this. I was impressed that I made this with pixel art. Hopefully you guys like that too. We have a gray car. We have a bunch of other cars as well. I just made a bunch of different colors, so you guys could swap the colors if you want, but I'm using green and red. And then obviously we have the red car. And then we have our track border. I'll discuss why we need this in a second. And then we have our track. So notice this track kind of has some white outlines. The reason for that is I took this from Google Images and then removed the background from it in Photoshop. I'm not very good at doing that, so that's why it looks the way it does. Feel free to use any track that you want, but what you will need if you use a different track is you will need the border, or kind of like the, I guess you'd call it border. I guess you could call it the walls or the outline of the track as well. You'll see why we need this, but this is how we're going to handle collision, by using kind of just the edges to determine if our car has actually gone off of the main track. And that's how we're going to bounce our car backwards. So again, you need the main track like this, and then you would need the track border. You could do it with just the border as well, and then you could have some background kind of beneath the border. You'll see what I mean in a minute, but I'm kind of just explaining why we have these two images here. Then, of course, we have the white car. Again, this is just so you guys can have some options when we're using the cars. Great, so download all of those. Again, link in the description. It should download a zip folder, and then you can extract the zip folder, by right-clicking on it and get all of the images. Now that we have that, what we need to do is install pygame. So what you're going to do is go in your terminal or command prompt and type pip install pygame like that. Now, if for some reason this doesn't work, I have 2 videos on this channel. I'll link them in the description as well. They'll walk through all of the possible ways that installing pygame could go wrong and how to fix them. So I'll refer you to those 2 videos there if for some reason you cannot install pygame. So watch those and then come back. Great. Obviously, I already have pygame installed, so we are good to go. Now that we've done that, I'm going to make a Python file. In fact, I already have one called main.py outside of the images directory, but inside of the folder where my project is going to be. All right, so now that we've got all of that set up, I'm inside of the main.py file, and we're going to start writing some code. Now, the first thing I'm going to do is just import pygame, because we're going to need that. A few other imports we'll need as well is going to be import time, and then I'm just looking at my cheat sheet here. In fact, if you notice me looking to the right, it's because I have all of the code already written, just so that I don't get lost as I'm going through this tutorial. We're also going to import math. We'll be using a lot of stuff from the math module. Now that we've done that, the first thing I actually want to do is just load in all of my images. The reason I'm doing that now is because we actually need some of the images to set up some other things you're going to see. So the first thing I'm going to do is load in my grass. So in all capitals, I'm going to say grass. The reason all capitals is because this is a constant. This is not going to change. So that's the convention. I'm going to say pygame.image.load, and then I'm going to put the path to my image, which is going to be images / and then grass.png like that. So now I have my grass. Next, I'm going to load my track. So I'm going to say track is equal to pygame.image.load. It's going to be images / track.png like that. After we do that, we will load in our track border. So I'm going to say track _ border like that is equal to pygame.image.load, and this will be track - border. Let's make sure that's the correct name. Looks like it is. Okay, great. And now that we have the track border, we can load in the finish line. So I'll just say finish is equal to that, and then this will be finish.png, and then we can load in our cars. So we will say red car is equal to, and then this will be red - car, and then we will have our green car. Let's make sure that's all capitals, and then green car like that. Now, of course, feel free to swap these cars if you want. I don't think I need to explain how to do that, but you would just change the name inside of here and then the corresponding variable name. Great, so now that we've done that, what I want to do is start displaying some of these images on the screen. But first, I need to actually set up a screen or set up what's known as kind of the display surface. So what I'm going to do here is say that my window, or my win in all capitals, is going to be equal to pygame.display.set_mode, and then the mode that I need to set inside of here is a tuple containing the width and the height of my display. Now, the width and the height of this display, I actually want to be equal to the size of my track. So whatever the track size is, that's how big I want my pygame display to be. So what I'm going to do here is say width, height is equal to, and then track.get_width, and then track.get_height like this. So a little trick in Python, whenever you have a surface, which is what this does, it loads in an image and renders it as a surface or stores it as a pygame surface. You can get the width and the height of that surface by using get width and get height. So we're going to get the width and the height of our track, and then I'm going to say that I want a display that is of size width height, and that is obviously corresponding to the size of the track. Now that I have set up the window, I'm just going to give my window a name. So I'm going to say win dot, and then this will be set _caption like that, and I'm just going to say racing game ! Like that. Okay, so now that we have our window set up, we should see if we run the code here. Let's see, no such file or directory, images grass.png. Okay, that's interesting. Let's see why that's happening. Oh, it's grass.jpg. Well, that makes sense. So let's fix that. Let's run this now, and then we should see a pygame window pops up, and then it just immediately goes away because apparently it has no attribute set caption. Interesting. I believe that's because this is actually the correct one. pygame.display.set_caption. My apologies again. That's going to happen a lot. I'm going to make mistakes in this video. Let's run this code now, though, and see what we get. And there we go. Perfect. So everything is working as we would expect. The reason the window is not staying on the screen is because we haven't made it stay on the screen yet. Okay, so now we have loaded in some of our images. The next thing that I want to do is actually show some of them on the screen. So I'm going to set up my event loop. I'm going to say while run, and then I'm going to make a variable here that says run equals true. Now, the event loop in Python is kind of a constant loop, or in pygame, sorry, that is going to be handling all of your collision, all of your movement, all of your events, like the user pressing a key. And so the first thing you usually do is you set up this main event loop, and that's what keeps the window alive, right? Keeps it running on the screen. And then as soon as you quit the window or the game ends, then you would destroy the event loop and destroy the game, and then the window would disappear. Hopefully that makes a bit of sense, but we're going to say run equals true while run. Now inside of here, I'm going to say the following: for event in pygame.event.get. This is going to give us a list of all of the events, and then we can loop through them. And the first event that we want to check is if the user has closed the window. So if they press the X in the top right-hand corner. So the way we do that is we say if event.type is equal to pygame.quit, then we're going to say run is equal to false. We're going to break out of this for loop right here. And then underneath this while loop, I'm going to say pygame.quit. Now this will just close the window cleanly for us. So the idea is if we press the quit button, we make run equal false, we exit the while loop, and then, well, we would quit the game. Awesome. So now that we have that, if I run my code, we should see that it says racing game, window shows up, everything's fine. And then if I click X, it closes. There we go. And that is some good progress. Okay, so now that we have that, what I want to do is set up a clock. Now, what a clock does is make sure that our window is not going to run faster than a certain frame per second, or than a certain speed is probably what I should say. So right now, this while loop is going to run as quickly as our processor can handle it. So if you have a really quick processor, it's going to run faster than if you have a really slow processor. But the thing is, when I have this game, I want it to run at the same speed on every single person's computer, right? Or I want it to at least have a maximum speed so one person can't be going like super fast down the track. Meanwhile, on a slower computer, they're going really slow just because their processor can't handle it. So I'm going to set up a clock, and this clock will fix that for us. So I'm going to say clock is equal to pygame.time and then .clock with a capital C. Then up here, I'm going to say FPS, standing for frames per second, is equal to 60. Right at the top of my while loop, I'm going to say clock like this, .tick, and I'm going to tick by FPS. Now what this does is make sure that this while loop cannot run faster than 60 frames per second. Okay, so if you change this number, then that will change how quickly this while loop can run. Hopefully that makes sense, but if we run the code now, we should see that it's just working the exact same. We're not really going to see a difference because we're not drawing anything on the screen. Okay, so now that we've done that, I want to draw some of these images on the screen and just see the size of them, and then we're going to kind of position them and redraw them just to make sure they look good. So let's go inside of here, and let's start by doing this. Pygame.display, not clear, but .update. Now, this is a method that you need to run every single time you want what you've drawn on the screen to actually be drawn. So what you can kind of do in Pygame is you can draw a bunch of stuff, and then as soon as you've drawn it onto the screen, you update the display, and then it will show all of the stuff that you've drawn. So in this case, I want to start by drawing this grass background and the track over top of it. So let's do that. We're going to say Pygame. Actually, not Pygame. We're going to say win, which is the name of our window, .blit. This is what you do when you want to draw an image onto the screen. We're going to put the image we want to draw. So I want to draw grass. And where do I want to draw this? At position 0, 0. Now, the coordinate system for Pygame is 0, 0 is at the top left-hand corner. I guess top left would be there for you guys. And then as you go down, the Y increases. So the bottom of the screen would be the largest Y value. And as you go to the right, the X increases. So the furthest right would be the largest X value, sorry. So yeah, the X increases as you go right. Perfect. So let's run this now. Let's see if grass is showing up. And notice grass is showing up. Now it's not quite large enough. We'll make it larger in a minute, but for now we can see it on the screen. So now that we've done that, we want to draw the track. So I'm going to say win.blit and then track like that. and we'll draw the track at 0, 0. Now notice the order I've drawn this. I've done the grass first and then the track second. That's so the track will show up over top of the grass. If you did it in the other order, well, you would get it in the other way. Let's run it now. And notice now we have our track and that the size of the window is exactly kind of the size of the track here, right? So now what we need to do is draw the finish line, and we also need to increase the size of the grass. And I actually want to make the track a little bit smaller because it's taking up a bit too much room on the screen for my liking. So let's just draw the finish line now. We'll say win.blit like that, and then we'll say finish, and we'll just draw this at 0, 0 as well, just so we can see what it looks like. And then that's the finish line. That might actually be a good size, but we might need to make that a bit smaller as well when we change the size of this stuff. Okay, so now that we've done that, we need to change the size of some of these images. So to do that, I want to write a function. The reason I want to write a function is it's just going to make it a lot easier for us to scale our image rather than having to manually write the same thing a bunch of times. So I need to go look at my cheat sheet here, and we're going to write the following function: define scale underscore image. This is going to take in an image and a scale factor. Now the factor is like if I give 2, it's going to scale it by 2x. If I give 0.5, it's going to shrink it by a factor of 2, or shrink it, or I guess multiply it by a factor of 0.5, right? Whatever way you want to think of it, but that's kind of how it works. So now I'm going to say the size, this will be the new size, is going to be equal to round, and then this is going to be image.get underscore width multiplied by the factor. The reason we need to round this is because we need to have integers when we scale the image. We cannot have decimal values. So we'll do that. Now let's copy this. We're going to go comma, and instead of get width now, we're going to do get height. And again, we're going to multiply it by the factor. So this will give us a tuple that contains the new width and the new height of our image. Then what we're going to do is return like this, pygame.transform.scale, and then we're going to pass the image, and we're going to pass the new size that we want this image to be. Let me make sure that's right. Looks like it is. So that will allow us to scale our image. Now the thing is, I don't really want this function kind of cluttering up my main file. So what I'm going to do just to clean things up a little bit here is I'm going to make a new file called utils.py. And inside of utils.py, I'm going to put utility functions that are going to be used from inside of this main file. So inside of here, I'm just going to import this function. And at the top of the program, I'm going to say import pygame like that, just because we need access to pygame in here to use this pygame function. Great, so now rather than having this function here, I'm just going to say from utils import, and we will import scale underscore image like that. Great, so now we can use scale image. So the first thing I want to do is I want to scale my grass. So I want to say scale image. I'm going to pass this image to scale. And then what do I want to scale it by? Let me check here and see. For now, we'll try with 2.5. We might want to change that, but that's what we'll go with right now. And then for my track, I don't really want to shrink this too much, but I want it to be a bit smaller. So I'm just going to scale it by 0.9. Okay, so now we've scaled the track and the grass. While we're at it, I'm just going to scale the track border to be the same size as my track. The reason for that is I need the border to be the same size. Otherwise, we're going to have some weird collision errors in the future. So let's make this 0.9. And then the finish line we'll leave like that for now. Okay, so let's run this. And notice that that looks a little bit better. The grass is taking up the full screen. Track is a bit smaller. Everything looks good. Now let's just draw a few cars and then let's scale those. So let's go down here, and rather than blitting the finish line, let's blit a car. So let's just go with red underscore car. All the cars are the same size, so if you scale one, you can scale all of them. Notice the car is a little bit big. I'd like that to be a bit smaller because we want to be able to fit 2 cars on the track kind of parallel or beside each other. So let's make the car a bit smaller. Let's go to red car. Let's go scale image, and that should not be in all capitals. Let's go scale image like that. And we're going to scale this to 55%, so 0.55. And then we'll do the same thing here, scale image, and 0.55. Okay, now let's run it, and let's look at our car, and that is a much better size. Sweet, so now we have drawn pretty much what we need to onto the screen. However, what I would like to do is kind of clean this up a bit, and you're going to notice we're going to continually be cleaning and refactoring stuff as we go through this. I want to take all of the stuff related to drawing, and I want to put this in a separate function just to make sure that I know where all of my drawing's being done, and I'm not drawing, like 100 things inside of this while loop, because that's going to get really messy really quickly. So I'm going to make a function up here called draw. Now, the reason I'm not going to put this inside of the utils function is because this is very heavy or very correlated to the game, whereas the stuff inside of utils.py, I could use this in any game, whereas this draw function is going to be used only in this game, right? So it kind of makes more sense to be in this file. Anyways, I'm going to take a window that I want to draw stuff on, and then I'm going to take images that I want to draw. And then inside of here, I'm going to say for, and we're going to go with img in images. I'm going to say win.blit, and then I'm going to blit the img, and we're actually going to say img comma pause, and you'll see why in a second, and I'm going to blit it at this position. Now what I'm going to do is I'm going to say my images are equal to, and I'm going to make a list containing images and their positions that I want to draw them on the screen. So I'm going to say grass, and I want to draw this at 0, 0, and then I'm going to say track, and I again want to draw this at 0, 0, and for now we won't draw the car, we're going to draw that a bit differently. So now inside of here, I need to call this draw function. I need to pass in my window, which is a capital win, and then my images like that. So now if we run the code, we should get the same thing we got before, and we do. All is working. Okay, so that is all good. Now we want to draw the car, and we want to move the car around the screen. And the thing with the car is that we need it to be able to change its position. We need to be able to rotate the car, right? So it can go left, it can go right, because that's how we're going to be able to turn. We have to be able to turn around the track, and well, we need to turn the heading of the car. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. They have over 160 coding interview questions on the platform, and I am one of the instructors on that platform, so you can be sure there are great explanations for each of those questions. Check them out from the link in the description, and use the code TechWithTim for a discount on the platform. So what I'm going to do here is set up a class, and this class is going to handle all of that stuff for our car. So I'm just going to say class, and I'm actually going to make what's known as an abstract class. I'm going to say abstract car like this. Now, you'll see why we need this in a minute, but the idea is we're going to have both a player car and a computer car, so there's going to be a lot of stuff that's common to both of these cars. So we're going to put all of the common stuff in an abstract class. This is a class that's not meant to be instantiated, but that's meant to act as the base class for the other two classes. If you're not familiar with inheritance, don't worry about it too much. Just understand that all of the stuff I put inside of here is going to be used by both my player car and my computer car, and that's the point of this. So inside of abstract car, I need to go and look at my code here to remember what I put. I am going to define an init. Now I'm going to say define init like this. And inside of here, we're going to take self. We're going to take a x and a y. Actually, no, we don't want an x or y. We're going to go with max velocity as our first parameter. And then as our second parameter, we're going to go with the rotation underscore velocity. So the reason I want both of these is because I want to know the maximum speed my car can go, so the maximum velocity. And I also want to know how quickly my car can rotate, so it's rotation velocity. And then inside of here, I'm going to say self.max underscore vel is equal to max underscore vel. I'm going to say self.vel equals 0. The reason why the starting velocity is 0 is because your car's not moving when it starts. It has a velocity of 0. And then I'm going to say self.rotation velocity is equal to rotation vel. I'm then going to say self.angle is equal to 0. And the point of this is that our car will start at an angle of 0. And then when we change the angle, that will change the way that the car is rotating. Okay, so now that we have that, the first thing I want to handle is just rotating the car. So I'm going to go inside of here, and I'm going to say define rotate like that. I'm going to take a self, a left is equal to false, and a right is equal to false. Now you're going to pass left equals true if you want to rotate to the left, and right equals true if you want to rotate to the right. Now inside of here, all I need to do is say if left, I'm going to say self.angle, and then this is going to be plus equal, and then self.rotation velocity like that. And then if we are moving to the right, it's going to be the opposite. So we're going to say elif right, then self.angle minus equals self.rotation vel. And now that I'm thinking about it, when I'm going to the right, my angle is increasing. When I'm going to the left, my angle is decreasing. So I actually think it might need to be the other way around. Or maybe I'm crazy here. You know what? We'll leave it like this for now. And if for some reason we're rotating in the inverse direction, then we'll change this. I think this is right. I'm just confusing myself. Okay, so now we have rotate. I'm just looking at anything else we might need here. For now, that actually looks good. So what we can do is call the rotate method, and then depending on if we're going left or right, we'll rotate to the left or right. The way we rotate is by changing the angle. However, we need to actually rotate the car, right? We can change the angle in this class, but that's not going to change the position of the car image. So what we need to do is find a way to actually draw the car image rotated. So we need to know how to rotate the image in pygame. Now this is a little bit complicated, but I'm going to go inside of utils.py, and I'm going to write a function that can take an image and return to you a rotated image based on an angle. So let's do that. We're going to say define blit underscore rotate underscore center. And what this is going to take is a surface. This is where we want to draw the, actually let's call this win. This is where we want to draw the rotated image. Then we're going to say the image. We're going to say the top underscore left, and we're going to say the angle. Okay, so I'm just going to write this function, then I'll explain a little bit about what's going on after. But I will note that rotating an image in pygame is not trivial. If you're going to be rotating an image, you can just normally rotate it, but if you do that, you're going to get all kinds of distortions. And the reason for that is the rectangle that contains the image. So I should say every single image in pygame is really a rectangle, and then the actual image is inside of that rectangle. So even if it doesn't look like a rectangle, there is a rectangle that's containing the image. So when you rotate the image, you're also rotating the rectangle, and based on the position that you're rotating the rectangle around, you can get really kind of weird, like, morphing and distortions occurring with the image. So that's why we need whatever we're doing here. So I'm going to say rotated image is equal to pygame, and I believe this is .transform. It is .transform.rotate, and we're going to pass the image and the angle that we want to rotate. Now what this will do is rotate the image around the top left-hand corner. Now that's no good. We don't want to rotate the image around the top left-hand corner because that's going to lead to us kind of having like a circle around that stationary point. Instead, we want to rotate around the center of the image. So the way we're going to do that is we're going to say new rectangle is equal to rotated image like this. And this is going to be .get underscore rect. And we're going to say that the center of this rect is equal to image dot and then get underscore rect like this. And we're going to say that the top left, so top left like that, is equal to the top underscore left. And then inside of here, we're going to say dot center. Okay, so what's happening here is pretty complicated, but I will try my best to briefly explain it. I have to admit, I did take this code from Stack Overflow. I didn't come up with this on my own. Anyways, point being, we rotate the original image. When we rotate this image, I'll show you in a second, we get all kinds of weird distortions, and the actual X and Y of the image is going to change based on how it's rotating around the top left-hand corner. So then we have our new rectangle. So we say the new rectangle is equal to the rotated image.getRectangle. The point of this is we want to remove the offset, so we want to make it so that we rotate the image without changing the X and Y position of the image on the screen. That's what this whole line is trying to do for us. So we're saying let's get a rectangle from the new rect, but let's make its center equal to the image, the original image, its rectangle at the top left-hand corner position, and then whatever the center of that is. So we're getting the original image. We're saying the top left-hand corner of that original image is equal to whatever its X and Y position is, because the image doesn't know its X and Y position. So we need to set the top left-hand corner explicitly to be equal to that. Then we're saying, let's get the center of that. And wherever that center is, the new image needs to still be on that center. So that way we're only rotating from the center of the image, not from the top left. But we had to originally rotate from the top left because that's the only way to rotate an image in pygame. Hopefully that makes a little bit of sense. And then what we're going to do is say this. We are going to say win.blit, and we're going to blit the rotated image. And we're going to do this at the new rect.top left. So the whole idea of this new rectangle is to find the correct X and Y position of the new rectangle such that it's going to be in the same position as it was before, but now it's rotated. All right, a lot of complicated code there, but there you go. That will blit it and rotate it in the center for us. So let's go to main.py now, and let's define a method inside of abstract car that can draw the car for us. We're going to say define draw, and then we're going to take in self, and we're going to take in a window. All we're going to do is the following. We are going to say, first we need to import this. I believe this was blit underscore rotate center. Yes, it was. So we're just going to say inside of here, blit underscore rotate center, and then we're going to pass self.img. Actually, we're going to pass win, and self.img, which we've yet to define, which we'll do now. So we're going to go to abstract car. We're going to say self.img. Actually, not up here. What am I doing? Sorry, we're going to do it inside of here. We're going to say self.img is equal to, and then here I'm going to say img is equal to, and we are just going to reference one of the images that we want for this car. So in this case, I want the red underscore car. I'm going to say self.img is equal to self.img. Understand this is a little bit weird. What we're doing here is saying the following. We're going to store inside of the class the image that should be used for this class. So in this case, I want it to be a red car. Then I say the self.image, so the image specific to this instance, is equal to self.img, so whatever the image is here. And then inside of here, we then reference that image so that we can rotate it and, well, split it in the center. Okay, that's all great. However, I need to first make a way to actually rotate my car before we can see if this is working. So let's actually just draw the car first. Let's make a car. I'm going to say car is equal to, and first we should create a concrete instance of this class. So I'm going to say class, I'm going to go with player car like that. Now inside of here, all I'm going to do is just copy this. I'm going to remove it from abstract car because now we have this class. And that's actually all I need inside of player car, but I need to make sure I inherit from abstract car. So let me just explain this quickly in case this is a bit confusing. We have the abstract car class. This defines a bunch of functionality. When we put it inside of the brackets like this, we're saying we're going to use everything from inside of here. So imagine all of this is just copy and pasted right inside of player car. The only thing we're doing differently here is we're defining image inside of here, and then it will be used inside of the initialization when we instantiate this car class. Okay, that was a lot of big words, but let's continue. So I'm going to go here and say car. Actually, we'll go with player underscore car is equal to player car like that. Now we need to pass to this a maximum velocity and a rotation velocity. So for now, I'm going to go with 4, 4. Feel free to change that to make it slower or faster. Obviously, the higher number, the faster it will go. And now let's just draw the car. So inside of draw, I'm now going to pass my player car. So that means we need to now take player underscore car. And now we're going to say player underscore car dot draw. And then inside of here now, I'm going to take my pygame.display.update. I'm just going to put this right inside of the draw function so that everything related to drawing is contained in one place. Okay, so that should draw our car. Let's see if this is working. And missing one required positional argument win. Okay, player car.draw, that would be right here. So we just need to make sure we pass our window to the draw method. So let's run this now. And we got an error. Blit rotate center, missing 2 required positional arguments, top left and angle. Of course, I forgot those. Let's fix that. So we need to pass the top left-hand position. Now the top left-hand position is actually going to be equal to the X and the Y of the car, which we haven't defined yet. So we're going to do that now. We're going to say self.x, self.y is equal to self.start underscore position. Pause like that, sorry. And then inside of here, we're going to say start underscore pause is equal to, and then we're going to define what the starting position should be. So I'm just going to say, actually, let me just go look at my other code and see where I started it before. I was starting it at 180. Was that right? Let's see, 180 and 200. Okay, so we'll go 180 and 200. Okay, so now our self.x and self.y is equal to the starting position, which we've defined here. And inside of here, we now need to pass that. So we're going to say self.x, self.y, and then we want to pass the angle. And the angle is just going to be self.angle like that. Okay, let's run this now, and let's see what we get. Okay, so there we go. Our car is now drawn here. Now, let's just see if changing the angle actually does anything. So let's go and make the angle 90. Let's see where we go now. Notice we are facing left. Perfect. That's what we would expect, okay? Now let's make the angle 180. We should be upside down now. And there we go. So we are getting the car in the correct position. Sweet. So let's make that back to 0. And now let's make it so we can change the angle based on pressing a key. So we're going to go and I'm going to write the following inside of my main event loop. Remember, anything in the event loop is kind of handling events, handling collision, handling all of those types of things. So this is where we would put, key presses and moving the car. So I'm going to say keys is equal to pygame.key.get underscore pressed like that. And then what I want to do is check if we pressed a specific key. So I'm going to say if keys, and then I'm going to go pygame.k. Notice that's a capital underscore and then A. So I want to use WASD to move my car. So this would be left if I'm pressing on the A key. So if I'm doing that, then I want to say player underscore car dot rotate left is equal to true. Okay, let's copy this. And then let's go here and say if keys pygame k underscore d. So this would be right. Then I want to say right is equal to true. Okay, so that should now allow us to actually rotate our car left and right by clicking on A and D. If you're wondering how you find other keys, you can look them up. There's a bunch of, I guess these are called constants in Pygame, but you also can just do K underscore and then whatever the lowercase letter is of the key that you want. If you want like a space bar or something, then you would go all capitals and you would go space. Same thing with like shift or enter or any of those keys. If it's not just a standard character, then it's usually in all capitals. Okay, well, let's run this though, and let's see if it works. And now notice if I go left and right, I can rotate my car. And the speed at which I'm rotating my car is defined by that rotation velocity. So you guys can mess around with that, but if you change the rotation velocity, you'll notice you're rotating faster or slower. Okay, that's great. So we can now rotate the car off to a good start. That's actually a pretty difficult thing to do. So congratulate yourselves if you made it through that. Now let's see how we can move the car forward. So we have our self.velocity. We have the maximum velocity, we have the rotation velocity, we have the angle. The next thing we need is the acceleration because cars don't just instantly reach their top speed. They take a few seconds to get up to speed. When you slam on the gas, you are accelerating, you're adding more force to the tires, you're going faster, and then eventually you reach kind of like a terminal velocity, which is what we're going to get to here. So I'm going to say self.acceleration, did I spell that correctly? Looks like I did, is equal to 0.1. So this means every time that we are pressing down on, I guess it's going to be the W key to go forward, we're going to increase the velocity of our car by 0.1, let's call it pixels per second. That's maybe the unit that we're going at. If you want to accelerate slower, then make this 0.05, right? Or if you want to go faster, make it something like 0.2. Anyways, we have that. Now I want to define a method and I want to call this move underscore forward, okay? So define move forward. And inside of here, I'm going to take self. Now, all this is going to do is it's going to increase the velocity of my car based on the acceleration. And if I'm already at the maximum velocity, it just won't do anything, but it will move me forward. So inside of here, I'm going to say self.vel is equal to, I guess this is going to be the minimum. The minimum of self.vel plus self.acceleration and self.max underscore velocity. So what this is doing is saying, okay, well, if self.vel is already at the maximum, and we add self.acceleration, we don't want to go faster than the maximum. So we put self.maxvel here. So if this is greater than this, we just default to the maximum velocity. If it's not though, then we will increase the speed of the car by the acceleration. Remember the velocity starts at 0, okay? So that will increase our velocity. Now that's great, but we actually want to move the car forward. So to do that, I'm gonna make a new method called move. I'm gonna say define move like this. And inside of here, after I increase the velocity, I'm going to say self.move. Now, the thing is, inside of move, I need to actually calculate what direction I'm going to move my car. Because if I'm angled to the right or I'm angled to the left, then I need to move in that appropriate direction. I can't just go up or go right or go left. So I'm going to start by just showing you how we move in one direction. So I guess one plane or one dimension. And then I will show you how we can move in multiple dimensions. So move X and Y based on the direction of our car. And that's going to involve a little bit of trigonometry. Anyways, inside of here, I am going to say self.x plus equals self.velocity. So we're just going to move to the right based on whatever our velocity is. That's all we're going to do to start right now. Then we'll get more complex. Okay, so now that we've done that, we want to implement another key press to move the car forward. So I'm going to go here and say if keys pygame.key underscore W, then player car dot move underscore forward like that. So now as we press down the W key, we should increase speed. As soon as we get to the top speed, we'll stay at that speed and we'll move forward. Now remember, we're not decreasing the velocity here. So as soon as we hit the maximum speed, we'll stay at that maximum speed. Even if we let go of the W key, we'll keep going at the same speed. I'll show you how we fix that in a second, but just wanted to note that as we got in here. Okay, so I've loaded. Now notice when I press W, I move over to the right like that. Now I'm gonna stop as soon as I let go of the key, but when I press the key again, I'll be moving at the maximum speed. So that's it. That's how you move one direction, right? We just incremented the X of the car, and that moved our car over. Okay. That's great, but we ideally would like to be able to move in 2 dimensions. So this is where I need to pull out the Paint program and start showing you some trigonometry. Okay, so I'm here in Paint, and I'm going to start describing the trigonometry that we're going to use to actually move in the direction that we're facing. This is not trivial. This is why I'm in Paint. Now, please go easy on me. I am using my mouse, so this is going to be really rough, but it will give you kind of, what you need. It would give you the basic visualization of this. So the idea is we have some car. Let's say this is our car. Now, if he's just moving this way, all we have to do is move the Y direction, right? If he's facing completely up, then we can just move that direction. If he's facing completely to the right or completely to the left, any of these kind of polar coordinates here, then we can just go in those directions, right? It's very easy. We can just decrement the X, increment the X, decrement the Y, increment the Y. However, what happens if we're moving on an angle like this? Well, it is not so simple now to actually figure out how much we need to move this guy by, because we can't just move by the X and we can't just move by the Y. We need to move by both of them. We need to go some amount up, right? And some amount to the right. Now, first of all, what are those amounts? Well, if you said the amount is equal to whatever the velocity of the car is, that's incorrect. The reason for that is if my car has the heading like this, like it's pointing this direction, then the velocity that we have is in that direction, right? So let's say my velocity is 4. Well, if that's the case, then this is 4. That does not mean that my X is 4 and my Y is 4. In fact, I need to use this total velocity to determine how much X and how much Y I need to go by so that my total velocity accumulates 4. Because when I'm moving in 2 directions, I'm moving, 2 ways. And so I need to sum the velocities, but it's not as easy as just adding them together to determine what the total velocity is going to be. Now, in this way, we're going to go in the opposite direction. We're going to say the following. We're going to say, okay, well, this is like a right triangle, right? We want to go some direction X, some direction Y. So let's say X and Y like that. And then this is our total velocity right here. Now, it turns out that we know this angle. And if we know this angle, we can actually figure out what Y and what X are by using trigonometry. So there's a few very popular equations. The way I remember them is the following. We have SOH, which is SOH, and then we have CAH, CAH, like this. So CAH, and then we have TOA as well, TOA. Now, O stands for opposite. Now, this is relative to the angle that you're talking about. So if I'm talking about this angle right here, the opposite side is Y. So OHA, those are all sides, okay? That's side lengths is what I'm talking about. And S stands for sine, C stands for cosine, and T stands for tangent. Anyways, I have my angle. So the opposite side is this because that's kind of what the angle is like facing. It's what it's looking at. And the adjacent side is this. It's X because that's what's beside the angle. That's the way you can think of it. So if I want to solve for Y here, keep in mind I know my angle and I know my velocity. Then what I need to do is the following. I need to set up my equation. So I'm going to say that the sine of theta is equal to my opposite over my hypotenuse. Now, we know the angle and we know the hypotenuse. So H is really V, which is my velocity. Now, let's just plug in 4 because we know the velocity is going to be 4. We'll say the maximum velocity is 4, right? So now we're solving for O. And O is really equal to Y, right? Because that's the opposite side. And so what we do is we say that the sine of theta, which we can calculate, we can just take the sine of the angle, multiplied by 4, because we need to take the division and multiply it on this side, is equal to Y. So the sine of theta multiplied by our velocity gives us our displacement in Y. And then if we go to cosine here, it's just going to be the other way around. We're just going to take the cosine and we're going to multiply that by our velocity, and that is going to give us how much we have for displacement in X. So just basic trigonometry, but I wanted to walk you through that. All right, so hopefully that is a decent enough explanation. What we actually do in the code might differ a tiny bit just because of a few factors, but this is the general idea of how we can solve kind of two components based on one velocity and an angle. We're calculating the x and the y component. That's what they're known as because we can kind of call this a vector, right? Like this line right here. If you know anything about physics, you would call this a vector because we have a angle, so we have a direction and we have a velocity or a magnitude, and then we want to split it into its two components, x and y. Okay, so let's get rid of that and let's implement this. So let's go to our move method, and now rather than moving just by the velocity, we're going to do that kind of fancy equation that we just did. So the first thing I need to do is I need to convert my angle into radians. This is because we use radians in most computer math. Radians is just kind of a special way of calculating angles. In case you're unfamiliar, 360 is equal to 2 pi in radians, and 180 is equal to pi. Okay, you don't really need to know that, but just figured I'd let you know. So we're just going to say math.radians and then self.angle like that. Notice our angle is in degrees because that's how we want to rotate it. But then when we actually are looking for the components, we need it in radians. Now let's calculate the vertical displacement or the vertical velocity. So we're going to say vertical is equal to, and then this is going to be math dot, and I actually think this is going to be cosine for this, math dot cosine of radians multiplied by self dot velocity. And then we are going to say that the horizontal is equal to math dot sine of radians multiplied by self dot vel. Then I'm going to say self dot y minus equals vertical and self dot x minus equals horizontal. Now you can switch this to the plus sign and watch what happens, but the reason we need minus is because these are actually going to return to us in a lot of instances negative values. And based on the way that we are angling our car and just kind of some other things we've done that I don't really want to get into too much, we need to subtract rather than adding. Now, if we're subtracting, that means if this value is positive, we're going to the left, right? And if we are, and we're going up. So we're going to the left and up, which is the way that our angle is directing. So that makes sense. And then if this value is negative, that means that we're going to be going to the right and we're going to be going down. I mean, respective to x and y. Anyways, let's just run our code here and see if this works. And so let's do this. And now notice I can move in whatever direction my car is facing. There you go. So we are now moving our car, which I'm going to call a success. Now, the only thing we need to do here is we need to make it so our car slows down, because as you saw, let me actually run this again. My car just instantly stops, right? If I let go of the key, it just instantly stops. That's not realistic. Our car is going to have momentum. It's going to be moving, and it's going to take some friction to slow the car down. So we need some way to actually slow the car down when we're not pressing on the key, which is what we're going to do now. So we're going to implement a method here on our car, and we're going to call this reduce underscore speed, and we're just going to take in self. Now what we're going to do is reduce our speed by half of our acceleration. That is because we can accelerate faster than we can slow down. At least that's the logic that I'm going to use. I'm not sure if that actually applies in the real world, but that's kind of what we're going to do here. Also, just so that we don't slow down super, super quick, because we can accelerate really quick. Anyways, you'll see how this works as I get into this method. Now, I just need to look at where I have this in my other code so that I don't mess this up too bad. Okay, so we have reduce speed. What we're going to do inside of here is say self.vel is equal to the maximum of self.vel minus self.acceleration over 2. And then this is going to be 0. Now, the reason we have this is because if this value for some reason is negative, we don't want to be moving backwards. We just want to stop. And so that's why we have the 0 right here. So we change the velocity. And then since we have this move method already set up, we can just say self.move. So now when we reduce the speed, all that's happening is we're reducing the velocity by half of the acceleration, and then we're just going to move. And since this is set up, it'll just work. It's just going to move us slower in whatever direction we're facing. And while we're slowing down, if we're not on the gas, we can still turn, which is a very important thing to keep in mind. Okay, so now we have reduced speed. So what we're going to do is go inside of here, and we're just going to do something. I'm going to say moved is equal to false. And inside of here, I'm going to say moved is equal to true. Now, the point of this is that if we are pressing the W key, we don't want to reduce the speed. But if we let go of the the W key, we do want to reduce the speed. So now I'm going to say if not moved. So if I didn't press forward on the gas, reduce my speed. So I'm just going to say not self, but we'll go with player underscore car. and this will be dot reduce underscore speed. So now you should see that when I'm not pressing on the gas, I'm not pressing on the W key, we should reduce the speed. So let's run this code and let's see what we get. So now notice that we slow down, right? And it takes a second to slow down. I'm pressing the key, I let go of the key, and we continue going, and then we slow down until eventually we stop. All right, so with that said, this long video is now over. If you guys had the patience to sit through all of this, give yourself a pat on the back. I did not expect it to be this long, but there is a lot of stuff that goes into moving a car in this fashion. In the next video, we're going to set up the actual collision with the track. We're going to make it so you bounce off of the track. We'll then add a finish line, and we'll make it so that you can hit the finish line and collide with the finish line. So we'll just be doing collision pretty much in the next tutorial. Then after that, we will implement the computer car, so moving around a path, which is also not that easy to do. And then I guess we'll do 4 videos for this series. And in the last video, we'll implement all of the nice stuff like the text, showing the kind of the stats, the level system, all of that fun stuff. Anyways, if you guys enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in the next one. All right, so I am back with video 2 in this series. In this video, we're going to be talking about collision and handling pixel perfect collision, actually. Anyways, first thing I want to do is actually make it so our car can move backwards because, well, we didn't do that in the last video, and I meant to show that, so let's do that now. So to move backwards is very easy. In fact, it's the exact same as moving forwards, except we just need to modify the velocity and everything a little bit. So we're going to go and make another method here, and this is going to be called move backward. And inside of here, we're going to say self.vel is equal to the maximum of, and this is going to be self.velocity minus self.acceleration. When we move backwards, we need to subtract the acceleration because we're trying to go in the opposite direction. So we want a negative velocity to be moving backwards because it's like the reverse gear in your car. You don't turn around to go backwards. You can just rotate the wheels in the other direction, which is what we're going to do here. And then this needs to be self.maxvel over 2. I don't know why I deleted that. The idea of this is that we want, sorry, this needs to be negative, is that we want the maximum possible negative velocity to be half of the velocity going forward. The reverse gear in your car, you cannot go up to 100 miles per hour, right? You can only go a certain speed. There's a top speed in that. So same thing here. We're going to make it so when you go in reverse, you are going slower than when you are going forward. I don't know why that's super important, but that's what we're doing. So self.velocity minus self.acceleration, and then negative self.max velocity over 2, just splitting that in half. I think that's pretty self-explanatory. Let's now make it so we have a key that does that. So we're just going to copy this, and I'm just going to change this now to key. This is going to be S. S will go backwards, and then we will change this to be backward like that. Notice I have moved equals true. We need that to make sure we don't reduce our speed as we are going backwards. Perfect. Now that we have that, let's run the code and let's check if the reverse gear works. So now I can move backwards, and notice I cannot go backwards at the same speed that I can go forwards, right? I can go at half the speed. Great, there you go, backwards is working. If you try to turn when you're going backwards, you'll notice that the turning works, and you actually should be turning in the inverse direction, which is correct. And that's why we set up all this stuff so that it just works when we add other things in the future. Great, so what I want to do is just clean up the code a little bit here. I want to take all of this stuff, so keys, moved, all of the stuff related to moving my player, and I want to make a function here, and I'm going to call this move underscore player. Now inside of here, we will just take the player car. So we'll say player underscore car like that. And then we can perform all of this stuff simply using player car. Okay, so again, just trying to clean this up. So now inside of here, I'm going to say move underscore player, and I'm going to pass my player car. And this will handle all of the movement. Let me just get rid of that. Let's run this, and let's make sure it's still working. And it is. We are all good. Okay, one more small refactor I want to do is I just want to go and grab this reduce speed method here and put this inside of my car class. Reason being that my computer, which is going to inherit from this abstract car class as well, does not need to be able to reduce its speed. It's going to be the same speed the whole time. And so it makes sense to have this in the class where it's actually going to be used, because it's not going to be used by anything else that implements the abstract car class. You could leave it in there. There's arguments for both, but I am just going to move it here. Great. So everything will continue to work. We don't need to test that. Moving forward, though, the next thing I want to do is collision. So this is where we need to talk about masks, and we need to talk about how you actually handle collision of different objects in Python. So what I'm going to do is open up Paint here. and we're going to start talking about masks. All right, so I'm inside of Paint here, and I'm going to explain to you masks and how we do pixel perfect collision. So let's start with traditional collision, and then we can explain pixel perfect collision. So let's say we have some object, and let's just make it a circle for simplicity. Now remember I told you that every single surface in Pygame is really a rectangle. So even if this is all that we're showing, we actually have a rectangle around this circle here. So we might not see the rectangle, and the reason we wouldn't see it is because all of these pixels here would be transparent pixels, so they wouldn't show up on the screen, but they're still there. It's still a rectangle. So let's say we have another image, and let's just do it like this, and maybe inside of here, I don't know, we have some green, whatever, okay? This is what this image looks like. Point being is that these two rectangles, the rectangles containing these two images, are overlapping. This is the overlapping area right here. However, if we're looking at these two images, remove the rectangles, they're not colliding with each other, right? The pixels that are present in both of these images are not touching each other. But if we were to use traditional collision, which is just rectangular collision, you just check if two rectangles are lying inside of each other, then it would say that these two objects are colliding. And this is the overlapping area, but again, the pixels in the images are not actually colliding. So how do we fix this? Because I don't want it to show me that two objects are colliding unless the pixels on the screen actually look like they are colliding. This is where we use something known as a mask. Now, what a mask is an array of values representing whether or not a pixel in an image is transparent or present, whether it just exists. It's not a transparent pixel. Now, the point of a mask is that rather than performing rectangular collision like this, we can simply check if pixels that are not transparent are overlapping into rectangular regions. So let's clear all of this, and now let's look at an example of a mask. Let's say we have a very simple image. Okay, I'm going to just go with a rectangle because it's easier here. And we have maybe something like this, okay? We have pixels all in here, pixels all in here, and then inside of the other two regions is transparent, okay? And now we have another image, and let's just do something like this, and maybe we only have pixels inside of this bottom left-hand corner. Well, the mask for these two images would look like this. It's just going to be an array, so we'd have a large array. It's going to be a two-dimensional array, and we would have 1, 0, okay? And again, excuse me, I'm using the mouse here, and then 0, 1, like that. Now for this image, it would be similar, but we're going to have nothing in the first row because we have no non-transparent pixels. And then we would go here and we would have 0, 1 like that. Okay. Now let's imagine these masks are directly on top of each other. The two objects are completely on top of each other. Then what we would do is we would just compare values in these arrays and see if two 1s are at the same position, right? So we check here. So, okay, there's no 1 here. So we're not colliding in this region. Okay, then we go here. So, okay, there's no 1s there, so we're not colliding there. We go here, okay, no 1s, we're not colliding. And boom, we find two 1s, which means we're colliding in this region right here. And so we would say, okay, yes, we are colliding because two pixels that are not transparent are touching each other. There you go, perfect. That's all you need to know. However, it gets a little bit more complicated because we need to know the location of both of these masks before we can do this comparison. In the example I just showed you, we just imagined they were on top of each other. So if I select this and I grab it, it's going to be a bit rough, but we imagine this mask was right on top of the other one. And in that case, it was really easy to check if they were colliding. But what if the mask is sitting somewhere like this, or sitting here, or sitting up here? Well, we need to know that, and that's known as the offset. So we have something, and actually let's make a new file here. We have something known as our calling mask, and then I guess the mask that it's being called on. So let's say that this here is our calling mask, and then this is the mask that this mask is being called on. Well, we need to determine the difference between the top left-hand coordinates so that we can overlap these masks in the appropriate region to determine if pixels are colliding. So I want to calculate the displacement in X and the displacement in Y, so then I know the total displacement, and then I can align these masks properly before I do the collision. So if this is my calling mask, and this is the mask that I want to find the offset on, well, I just need to find that. I'll show you how we do that in code. And then that's one of the values that we need to pass to kind of our mask collision function so that we can overlap these masks in the correct area. All right, that's my explanation of masks. Hopefully that was good enough for you. Now we are going to actually do this. First thing we need to do, though, is create masks. So to do this, we're going to say track underscore border underscore mask. Now, this is the whole point of having this track border, is that we're going to use this border, let's go to it quickly here, as our mask. This will be one mask, and then we will compare this to the car, our player car, and we will see if these two masks are colliding with each other. And this is actually really easy to use because its corner is 0, 0, right? Its top position is 0, 0, which actually just makes it way simpler for us to do the offset calculation. So I'm not going to do scale image. I'm going to do pygame dot, and this is going to be mask dot from underscore surface. And we're just going to pass in here the surface we want the mask of, which is our track board. Easy enough. That's how you get a mask. Okay, so we have that mask. Now what I want to do is make a method inside of my abstract car class. It will go inside of abstract car because this is going to be for both the computer and my player. And I will call this collide. Now we're going to take in self mask x equals 0 and y equals 0. With the point being, we are going to pass some other mask here. We'll generate a mask for our own image. We will then have the x and the y of the other mask. We obviously already have the x and the y of the car. We will determine if two masks are colliding in here. So I'm going to start by saying car underscore mask is equal to pygame dot mask dot from underscore surface. And this will be self.img, so whatever image we're using for this car. Then we are going to calculate the offset. Now the offset needs to be integer values, so keep that in mind. So I'm just going to say int like this. And the reason we need that is because we could get some floating value when we do this subtraction. But we need to calculate the offset x and the offset y. Now the offset is relative to the calling mask. In this case, we're going to say, I guess, collision, or we'll actually go with POI, which stands for point of intersection, is equal to, and then this will be mask dot, and I believe this is called overlap of the car mask with the offset. So we're going to use the other mask as the calling mask, which is going to dictate how we calculate the overlap. If we did it the other way, we need to flip the offset, sorry. Okay, inside of int, I'm going to say, we're going to go with x minus self.x and y minus self.y. Or is the other way around? Let's see. Of course, I've done it incorrectly. It's going to be the other way around. It's going to be self.x minus x and self.y minus y. Okay, so the reason why we're using this as our offset, again, is because the calling mask is the other mask that we're passing. So we're going to take whatever our current x position is and whatever our current y position is, and we're going to subtract that from the x and the y of the other mask. Now that will give us the displacement between the two masks. If we did this the other way around, that'd be fine, but we would then have to swap this and say the car mask is calling the other mask, okay? So that's how that would work. Hopefully that makes a bit of sense. The reason we're converting this to int again is because we need integer values for the offset. We cannot have floating points, and our self.x and self.y can be floating point values. Okay, so now that we have that, this is going to return to us the point of intersection between these two masks if there is one. Now, we don't actually care what that point is, at least not right now. We're just going to return the POI. Now what we can do to determine if two objects have collided is we can see if the POI is equal to none or not. If there is no POI, the two objects didn't collide. If there was a POI, then they did collide. So now we have collide. So I'm going to go inside of here, and I'm going to check for this collision. So I'm going to say if, and we're going to go car underscore player dot collide, and we're going to do this with, what mask was it? This was going to be the track border mask. And notice that I don't actually need to pass an x and a y here because the track border is positioned at 0, 0. Now, we actually haven't even drawn the track border, but that's fine because we don't need to. We don't need to draw the track border right now because we just know that it's going to be at the exact same position as where our current track is on the screen, because the track border and the track are the exact same size. They're pretty much the same image, except one is just the border, the other is not. So we don't need to draw it, but we can still use the mask, and we know its location is going to be 0, 0. Okay, so we have that. If player underscore car dot collide track border, we can say does not equal none there. Then what we can do right now is we can just print collide. And that way it's really easy for us to see if we actually have collided. We can just look in our console and see if, well, we had a collide. So let's run this, and pygame.surfaceObject has no attribute overlap. Okay, let me go here. Okay, car mask, pygame.mask surface, mask.overlap. I realized what I did here. I passed the track border when I meant to pass the track border mask. Okay, so make sure you've actually passed the mask. That was the point of creating it. Let's run this now. And okay, we're all good. So now watch what happens when I go into the wall. Notice I get a bunch of collisions. And then when I get off the wall, it stops for a second. And if I go back to the wall, it continues printing collide. Now you can't really see it because my whole console is filled with collide, but let's quit this and clear and run again. And I'll show you, let's turn and let's go here. And then we get a bunch of collides as soon as we hit the wall. Okay, so that is the idea behind the collision. That's really all you need to know for calculating collision. Now that we have done that, we need to do something when we hit the wall. We can't let our car drive through the wall. So what I'm going to implement now is a bounce. So if you hit the wall, you're going to bounce off the wall with the same velocity that you hit the wall with, right? I guess we could go into the laws of physics, laws of motion, maybe is what it's called. If you hit something with a certain velocity, then you're going to go back in that same direction, right? Just like when you throw a ball off of a wall, it comes back and you're going to lose a bit of velocity, but point being, law of physics. I won't explain more than that. So inside of my player car, I'm going to implement a method which is going to be bounce. I'm going to say define bounce self. Now, all I need to do inside of bounce is I just need to reverse the velocity. So I'm going to say self.vel is equal to negative self.vel. Now, this will work if we're going backwards or forwards, because if we're going backwards, the velocity is already negative. So this will then make it positive. So we go forward. And if the velocity is positive, then it just makes it negative, right? And then, of course, we'll just say self.move so that we start moving as soon as we reverse the velocity. So now all we need to do is here say self.bounce. And now if we hit a wall, we just bounce. And sorry, this is not self, this is going to be player_car. So if we hit a wall, we collide, we just bounce backwards, and we'll go in the same, well, actually the complete opposite direction as the one that we hit the wall at. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. They have over 160 coding interview questions in many different categories. They have heaps, they have arrays, they have linked lists, everything that you could imagine and that you need to prepare for your software engineering interviews is available at Algo Expert. Check them out from the link in the description and use the code TechWithTim for a discount on the platform. Okay, so now that we have that, let's run the code and see if this is working. And let's try it out. And notice that I am bouncing off the walls. There you go. That is what I would expect. Now, this is a little bit glitchy. I won't lie. This isn't always going to work perfectly every single time. And you'll notice that sometimes you will kind of hit a wall, even though you don't really see a wall. That's just because my image is kind of messed up a little bit the way that I had it. And so you might be hitting some pixels that you can't actually really see. Anyways, this is working good enough for me. I'm happy with the bounce. And so we're going to move on to the next thing. Okay, so we have now handled the collision with our walls. And you'll actually notice now that you can't go outside of those bounds because, well, you just can't, right? If you hit any of the walls, then you're going to bounce back inside. So now we need to make it so that you can hit the finish line, right? So let's start drawing the finish line on the screen. Let's handle collision with the finish line. But you'll notice that this is a little bit trickier than it seems because we have to know what direction we cross the finish line from. Because if the finish line is where we start, right, kind of starting line, finish line, if we just drive directly backwards, we can't say that we've won the race. We have to hit it from the other direction. So we have to handle that. Okay, let's go here though. We have finish. Now, let me see if I need to scale this rather than just messing around with it. Let's see if I did scale it in my my code previously. Looks like I did not scale it. So that's good. We can just leave it where it is. But I do need to determine the position of the finish line. So I'm going to say finish_position is equal to, and I've already figured this out for you, it's going to be 130 and 250. So now let's just draw this in that position and let's see what it looks like. So I'm going to go to my images here and I'm going to add that as one of the images. So I'm going to say finish. I'm going to draw this at the finish underscore position like that. So now let's run the code and let's see what we get. Notice the finish line is right here. All right, so there you go. The finish line is up. Now this looks fine. However, we can see it is kind of overlapping with our track. So what I'm going to do is just draw the track border over top of this. So that way we get rid of any of these edges that are being cut off. So this is kind of a neat solution that we can go with here. But what I'm going to do is just add inside of my images here. And make sure you do it after the finish line, by the way. Otherwise, it won't go over top of the finish line. I'm going to say track underscore border. And we'll just draw this at position 0, 0. Not 0M, 0, 0. Make sure we add our last bracket there. And let's run this now. And parentheses does not match. Did I mess something up? Okay, that looks good. All right, so now let's see this. And notice that now the finish line is no longer overlapping. The reason for that is it is actually overlapping, but we're just drawing over top of it just the track border. So that way, everything looks good. And then there you go. Our car is now moving around. Let's see if we bounce, and we do. Sweet. Okay, so that is good. Now that we have done that, we want to handle colliding with the finish line. So now we're going to do another thing down here. We're going to say if player underscore car dot collide, and now we need to get a a mask for the finish line. So let's generate a mask for the finish line. We'll do that from up here. Where is the finish line? Right here. Okay, we're going to say finish underscore mask is equal to pygame dot mask dot from surface and then finish. Okay, we now have the finish mask. So now we're going to say player car dot collide. We're going to go with finish underscore mask. And then we need to pass the finish position, but with an asterisk. What this does is split the tuple that is storing this position, so X and Y, into two individual coordinates and passes this to the function as two arguments. So if you do asterisk finish position, this is the same as passing 130 and 250. Okay, they're identical, but I figured I would show this to you because it's interesting Python syntax. Anyways, we're going to say again, if that is not equal to none, then what we want to do now is just print finish, okay? So now let's see if we can check for collision with the finish line. So I'm just going to go backwards and notice we get a bunch of finishes. And then if I go up here, we get finishes again. So the thing is, as I was saying, we don't want to be able to just drive backwards and say, oh yeah, you finished. In fact, if we drive backwards, we don't want to be able to go past the finish line. We should only be able to go forward on the track. We shouldn't be able to go backwards and cross the finish line. So this is where I'm actually going to use the point of intersection to determine what direction I hit the finish line from. So rather than just printing finish here, I'm actually going to store this. And I'm going to say finish POI collide. Yeah, I guess that makes sense. Finish point of interest collide is equal to that. And then instead of all this, we'll just say finish POI collide, and we will print out the finish POI collide. Okay, so let's run this. And now let's go backwards. And notice that we get a bunch of zeros as we're going backwards, right? So if I keep going back here, let's go back, back, back. Let's just go slow here. Notice all of these are 0, 0, 0, 0. Okay. And then as soon as, I guess, the top of my car kind of gets to the middle of the finish line here, we get some actual values for the y coordinate. So what we can do is we can just check if the y coordinate of the point of intersection is 0. And if it's 0, that means we hit it from the top, so coming down. If it's not, that means we hit it from the bottom and we actually finished, meaning we went all the way around the track. So let me show you what I mean. We're going to say if the finish POI collide at index 1 is equal to 0, then car.bounce. So just like when we hit the wall, this is actually going to be player car.bounce. We're just going to bounce, meaning we're going to bounce ourselves kind of up, I guess, if we're going backwards trying to hit the finish line. Let's run this. Notice when I go backwards now, I bounce forwards because I'm trying to cross the finish line from the wrong direction. Now let's go all the way around, and this will take a second here, but let's see if we bounce when we go from the other direction. Okay, we got to slowly make our way through the track. We can just test my driving skills here while I try to fill in the silence because there's nothing to talk about. Okay, looks good so far. Maybe we need to increase the speed of this car for debugging because this could take a long time if I leave it at the speed of 4. Okay, almost there. Last 2 bends here. All right, coming around, and notice we only bounce when we hit the top of the finish line, right? Like I can go onto the finish line like that. It's only when I get to the top that I'm actually bouncing. So that's exactly what we wanted. Now we can just implement what happens if we cross the finish line from the correct direction. So I'm just going to put in else here, because if we collided with the finish line, but our y coordinate was not 0, that means we actually finished. So in this case, we will just print finish, and I'll actually implement kind of the finish behavior in the next video. But for now, we can add a few more methods to our cars. So I'm going to go to my abstract car class here, and I'm just going to define another method. And I'm going to call this reset. Now, what this is going to do is reset our car position. So kind of preparing for the next level, right? So all we'll do is we'll say self.x, self.y is equal to self.start underscore position. We then need to reset the angle. So self.angle is equal to 0. We need to say self.velocity is equal to 0 as well. And then is there anything else that we need to reset? I don't think so. Let's see. Rotation velocity, max velocity. Nope, that looks good to me. We can just do that. Okay, so now how about we say that if we cross the finish, we'll reset the car. We'll set player underscore car dot reset. I'm just going to increase the speed of my car. So let's make this a speed of 8, and we'll go with rotational velocity of 8 as well, just so that we can turn at the same speed we can move forward. And let's run this, and let's see if we go any faster. Okay, so we can indeed go faster, but we do have to wait to accelerate. And oh gosh, that's a crazy bounce. Okay, maybe we should make the bounce a little less harsh, and maybe the lower speed was better. Oh my gosh. Okay, all right. Let's try to get around this bend here. Okay, yeah, so I think the speed of 8 maybe is too fast. We also could just try spawning the car right before the finish line. That would probably be easier too, but you guys can just watch me struggle here. Okay, let's go. And you're noticing that sometimes we're hitting like a wall that's not actually there. Again, kind of unavoidable, but as you saw there, as I hit the finish line, we spawned on top of the finish line. We reset the car and everything was good. Great. So with that, that pretty much covers everything I need to go through in this video. I'm trying to think if there's anything else I can show you, but I think for now that is fine. In the next video, we're going to implement the computer car, all right? So the computer car moving around. And as I said in the last video, we'll do all of the kind of logic of starting the different levels, moving the speed of the computer car faster, that nice fancy text on the screen, and really making the game an actual playable game. Anyways, I hope you all enjoyed. If you did, make sure you leave a like, subscribe to the channel, and I will see you in another one. Hello everybody, and welcome to the third video in this Pygame car racing tutorial series. In this video, I'll be implementing the computer car. So we're going to set up a path for this car to follow along with, and then we're going to make it follow the path, which is much more complicated than it seems. Let's get started. So the first thing I want to do here is make a class for my computer car. So I'm going to say class computer car like that. It's going to inherit from abstract car. And then inside of here, I'm going to define the image for my car as well as the starting position. So I'm going to say image is equal to, and this will be the green car, and the starting position will be 150. Okay, that's pretty straightforward for the computer car. Next, I'm going to override the initialization. So I'm going to say define init self. This is going to be max vel and rotation vel. It's giving me that. Very good. And then I'm also going to take in a path, which is going to be equal to an empty list by default. Then what I'm going to say is self dot, not self actually, super dot underscore underscore init underscore underscore, and I'm going to pass the max velocity and the rotation vel. What this is going to do is use this method right here to initialize all of the values that I need, and then I'm just going to initialize a few more under here. I'm going to say self dot path is equal to path. Path is going to be a list of coordinates of points that I want my car to move to. And I'm going to say self.current underscore point is equal to 0 because I need to know what point in my path I'm currently at. Then I'm going to say self.vel is equal to the maximum velocity because my computer car, we don't need to worry about acceleration. It's just going to immediately start at the maximum velocity and will move at that speed the entire time. Okay, now we have the computer car. The next thing I want to do is just implement a method on this car that can draw all of the points in the path, just because this will be useful for us to visualize. So I'm going to say define draw points, and then I'm going to say self, and we'll take in a window, and I'm going to say for point in self dot path. I guess we could have called that points too, but that's fine. And then we'll say pygame dot draw dot circle. And we'll draw this on our window. We need to pass the color of our circle, which is going to be red. So in pygame, the colors are RGB, so red, green, blue. So 255 is full red, 0 green, 0 blue. Then I'm going to pass the point. This is going to be the center of the circle that I want to draw. And then the radius will go with 5. So that means we're going to have a diameter of 10 for our circle. So that should draw all of the points for us. That's pretty straightforward. Okay, now we have draw points. Next, I want to make some feature that allows us to actually kind of click on the screen and, I guess, draw, create, select all of the points for our path. So that way we don't have to manually add them inside of this path variable. So you'll see what I mean in a second, but first let's create a car. Let's go computer underscore car is equal to computer car. We need to pass a maximum velocity and a rotation velocity. So for now, let's just go with 4, we'll match our player, although we will reduce this later. And then for the path, we won't pass anything right now because we're gonna kind of dynamically create the path. Okay, so now we've made computer car, let's draw it. So let's pass computer car to our draw function, and then let's go to draw. Let's take in computer car, and let's do computer car dot draw. And inside of here, let's draw on the window. And then what we will do is we will override the draw method in here. So we'll say define draw self win. We'll then say super dot draw. So we'll call the draw method from the abstract class here. So we'll do this. But before we do that, we will draw all the points, or after, it doesn't really matter, but we'll draw all the points. So we'll say super dot draw. We need to pass the win, and then we'll say self dot draw points and the window. So now when we draw our computer, it will also draw all of the points in the path for this AI computer, whatever. Okay, there we go. Now that we have that, let's just run the code and see if the computer is being drawn, and then we will continue. Okay, great. So the computer car is there. That's all we were looking for. Okay, let me clear the console here. Now let's continue. So the next thing I want to do is make it so we can click with the mouse, and that adds a point to our computer's path, and then we can get all of those points at the end of the program so that we don't have to manually write them. This is pretty easy. I'm going to go inside of my event loop here. So for event in pygame.event.get, I'm going to say if event.type equals pygame dot, this is going to be mouse button down like that. Then what we're going to do is get the position of the mouse. We're going to say pause is equal to pygame.mouse.get underscore pause. And this will give us the XY coordinate of our mouse on the pygame screen. Then we will say computer car dot path dot append position. So we'll add that position to the computer's path. Okay, that's really all we need to do, except at the end of our program, we're just going to print out the computer car dot path just so that we can copy it and then save it in our file and use it for future use. So let's run the code and let's see what we get here. Okay, we get our computer car. Now let's start adding some points. So I'm going to add one here. I'm going to add one here. And I will just add all of these. And then once I'm done, I will be right back. Okay, so I've added all of my points here. You can see this is kind of the path that I've defined. I've tried to spread them out as much as possible, but it doesn't really matter. I mean, just add the points and make them on the track, and you'll be good. You could put them off the track because we're not checking collision with the walls, but obviously the better you make your points, the better this is going to be. Now, I recommend you do spread them out a bit. If you make them too close, you're going to see it's going to look like all jittery when we're kind of turning and angling towards them. Anyways, that's fine. Okay, so let's close this. And notice when I close this, it prints out all the points. So what I'm going to do is copy all the points, and I'm just going to make a variable at the top of my program here called path, and I'm going to have it store all of these points, just so that I can use this with my computer, right? With my computer car. So now what I will do is I will actually go to where I initialize my computer, and I will pass that path. So now that will be set for my computer. And then I'm going to get rid of this mouse button down logic because I no longer need that because my path has been set. So now that I have the path, let's just run this. And notice the path is still printing out. It's, saved, right? Because I have it in a variable. Great. And then, of course, my red car can continue to move just like it did before. Awesome. So now that we have that, what I want to do is hop over to Paint, and I want to show you or discuss how we're actually going to kind of solve this problem of moving the computer car towards these points. And it's pretty complicated to do this, but I will try my best to explain. So let's say our target point is right here, and our computer is right here, okay? This is our computer car. So let's just go see, this is car. Now, the first thing that's kind of intuitive to do here is to draw a line between the top left-hand corner and the point that we want to get to. Now, we're going to be using the XY as the top left-hand corner of our car, so keep that in mind. That is pretty important for this. And anyways, there we go. So we have our target and we have, our car. Now, how do we get to this point? Well, the first thing we can do is we can calculate the displacement in X and the displacement in Y, right? So we know the velocity, but we do not know the angle. And so what we're actually going to want to look for here is the angle between our computer and this point. If we know the angle, then we can tilt our car to that angle, and then we can move in that direction. Easier said than done, but that's the goal. We want to find the angle between our car and the point that we want to get to, and then we want to set the car so that it's facing that direction, and then just move the car in the same way that we moved our player car, because we already know how to move the player car, right? That part is done. We've implemented that logic. So anyways, we have X and we have Y. Now, we can easily calculate X and Y because we know the coordinates of this point and we know the coordinates of this point. We would just take this point's X, subtract by this point's X. That gives us the displacement in X. This point's Y, subtract by this point's Y. That gives us the displacement in Y. Now, it doesn't really matter if we get negative or positive values. We could take the absolute value if we want, but it doesn't matter if we get negative or positive, okay? Finding the angle is still going to be the same. And then we have our velocity. Now, the velocity we don't really need to use, but we know the velocity is going to be the hypotenuse of the triangle. Okay, that's fine. So what we're trying to do here is determine the angle. We know X, Y, and V, so there's multiple ways to do this. Now, remember our equations are this is going to be an H. Let me erase that. So, Ka, and then Toa. Now, in this case, it seems intuitive to me to use Toa because we know the opposite and we know the adjacent. So what we can do if we want to solve for theta, which is the angle that we're looking for, is we can write the equation tan, and then this is going to be of theta, is equal to O over A. Now we can do our substitutions, and when we do our substitutions, we see that O is Y and that A is X. So we know X and Y, those are two variables that we know. So now we want to solve for theta. So any of you that know trigonometry know that we have to take the inverse tangent of this, and then that will give us theta. So we can say theta is equal to, and then tan inverse of Y over X. And then that will give us the angle that we're looking for. And in fact, this is actually always going to give us what's known as an acute angle. Now, an acute angle is any angle that's less than 90 degrees. Now, it will give us either a positive or negative acute angle. So we could get a negative value here or a positive value here. If we get a negative value here, that's indicating to us that we are looking to the left. If we get a positive value, then to the right. Anyways, that's not super important right now, but just keep in mind that this is how you calculate theta and that this is always going to give us an acute angle. That is important. It's always going to give us something based on the way we're doing this calculation that is less than 90 degrees. Okay, so now we have found the angle. So we found the angle between our car and our point. So it should be simple enough, right? Just set the car at that angle. Well, it's not quite that simple. The reason why it's not quite that simple is because if our car is like facing this direction and we want to go over here, if I just set its angle to that, it's going to look like it's just teleporting over. That would be the easy solution. Just set the angle and then that'd be fine. But if we do that, what happens is, first of all, we're going to have our car facing the wrong direction a lot of times. We're also going to have the car flipping instantly, which we don't want. We want it to kind of slowly transition to that angle by its rotational velocity. We don't want it to just teleport over and face that direction. So now comes the problem. Okay, we know that angle. We know the angle our car is currently facing. How do we determine what direction to turn the car to get to that angle? That's really the problem now. We know the angle of our car. Now we just need to actually make this car get to that angle. So there's a few problems here. Again, the first problem is that we need to make sure we aren't just teleporting. So we have to kind of decide, do we want to go to the left or do we want to go to the right? Now, this might seem easy when you're looking at an angle like this, but there's so many different angles we could possibly have. And sometimes we could take the unoptimal approach if we only ever went to the left or only ever went to the right when trying to get to these angles. So for example, let's say we have this. Okay, let's just move this over a bit. Let's say our target angle is here. Okay, and our car is facing this way. So car is black and the target angle is red. Now, what way should we turn to get to this target angle? Well, we should turn this way. However, we might end up turning this way. So this is kind of the problem. We need to figure out which way to turn. Now, another problem that we're going to run into potentially here is that we might have the angle be here. So let's imagine this guy is gone, okay? We might have it be here. Now, theoretically, me turning like this is actually going to make it look like we have the same angle. I know this seems really weird, but the way that this angle is calculated means that this could actually be this, or other way around. We could get this angle from this. So we need to kind of put in some checks here to ensure that if we're actually moving downwards, we're actually going to go in the downward direction. We're not going to mistakenly calculate this angle. The reason why this is a problem is because these two angles are the same, right? If you look at this angle and you look at this angle, they're the same. And so when I do the tangent based on the way that I'm doing it, I could get this when my point is down here. And so I need to make sure that I'm actually looking at what direction my point is in, if it's lower or higher than where I am. And based on that, I'm going to need to make an adjustment to the angle I get to ensure that I'm going the right direction. So I'm just trying to kind of point out some of the problems that you can run into doing this. And there's all kinds of other problems as well. For example, right, like I was saying, we might go and try to go like this when instead it would be more efficient to go like this. So if we ever have a very large angle, we'll actually want to reduce that angle to a smaller yet equivalent angle so that we end up moving in the, I guess, best direction, the quickest direction to get to it. I also realized that all of my lights turned off here. I'm just going to turn them back on. I'm sure you guys can still see my face fine, but I have like these background lights that for some reason went off. Okay, so that's a bit better. Okay, anyways, that was kind of the point of this. I'm sure this hasn't cleared everything up. I haven't necessarily stated the solution. I just wanted to show you problems that can happen. And really the main problem is, what direction do we go? Do we go left or right? That's the main idea. So let's now start trying to implement this. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. Not only do they have a ton of coding interview practice questions, they also have mock interviews, a data structures crash course, and a bunch of other awesome features to help you prepare to land your dream software engineering job. With that said, check out Algo Expert from the link in the description and use the code TechWithTim for a discount on the platform. I'm going to go into computer car and I'm just going to define a move method. Now this move method is special because when I'm moving, I need to move towards a point. So the first thing I need to do is angle the car in the correct direction. And if I am in the correct direction, then I can start moving towards that point. And we already know how to move. We can just use the move method that we have inside of here, right? If we're angled in the right direction and we're going by a static velocity, then that's fine. So I need to look at my other code here because it's very easy to mess this up. So inside of move, what I'm going to do is just make sure that we have a point to move to. I'm going to say if the self.current point is greater than or equal to the len of self.path, then I'm going to return. This is just going to ensure that we are not going to get an index error by trying to move to a point that doesn't exist. That's the point of this line. After that, I'm going to say self.calculate, and this is going to be angle. Now, we will write this method in a second, but this is going to calculate the angle and shift our car in that direction. The next thing we're going to do is say self.update underscore path underscore point. Now what this is going to do is see if we need to move to the next point, because as soon as we hit a point, we collide with that point, we then move to the next one. That's it. And then here, we're going to say super.move. So we're going to actually call manually the move method that we're overriding inside of car. Okay, so let's start by implementing calculate area or calculate angle. I'm going to say define calculate angle self. The first thing I want to do is calculate the displacement in X and Y between the target point and my current position. Once I do that, then I can find the angle between my car and the point, and then I can adjust the position or angle of my car accordingly to move towards that target point. So I'm going to say target underscore X, target underscore Y is equal to, and then this is going to be self.path at the self.current point index. This is getting our target point. Then I'm going to calculate the difference in X. I'm going to say the X diff is equal to the target X underscore X minus the self.x. Then I'm going to say the Y diff is equal to the target underscore y minus the self.y. Now, I don't care about the absolute value because my tangent function will actually handle any negative values here, and it can potentially give me a negative angle. We will handle the negative angles. The negative angle is just, going to, I guess, the right instead of the left, or the left instead of the right. Doesn't really matter. Okay, so now that I have both of these, I'm just going to say if y underscore diff is equal to 0, then the desired underscore radian underscore angle is equal to, and I want to say 180, but I want this to be in radians. Sorry, not 180. I want this to be 90. And so in radians, this is going to be math.pi divided by 2. Because math.pi is 180 degrees, 2 math.pi is 360. So the reason for this is that if the y difference is 0, I need to manually set the angle because my equation involves a division of the y difference, and I can't have a 0 division error. So you'll see what I mean here. I say else the desired radian angle is equal to, and this is going to be the math.arc tangent, so the inverse tangent of, and then this is going to be this is going to be x diff over y diff. Okay, so this is going to give me the angle that is between my car and between the point. And then same thing here, this will give me that angle. So if we have no difference in y, then that means that we're horizontal, right? We're either 90 degrees or we're either 270 degrees. Now in this case, we'll just make it at 90 degrees because 90 and 270 are equivalent angles, not in direction, but in like the magnitude of the angle if you divide them. Hopefully that's making sense, but we just need to avoid having an over 0. So that's why I'm writing this line here. Okay, now that we have that, what I want to do is I want to kind of implement a clause here that's going to fix this angle slightly if a certain thing occurs. I'm being very vague, but let's just write it. I'm going to say if the target underscore y is greater than, so is lower down on the screen than self.y, then what I want to do is say the desired radian angle plus equals, and this is going to be math.pi. So the reason I'm doing this is kind of what I discussed before. We can potentially have a problem where the angle that we calculate it's always going to be an acute angle, right? And so if the target that we're looking for is actually lower down on the screen than where our current car position is, the turn that we need to make is more extreme than what the angle is that we're getting. Maybe we're getting an angle of 25 degrees, right? And the reason we're getting 25 is because 25 kind of spans this whole horizontal line. And so we're looking at it like this, but what we really want is to add a whole math.pi, add 180 degrees to it so that we go in the complete opposite direction of what the angle is that we calculated because we're going down. Because remember, we're always going to get an acute angle, so we're always going to be going kind of this way or this way, so we need to figure out if we need to go the opposite direction down. Now, in that case, well, the case is this. If target y is greater than self.y, we're going down, so we have to add math.pi to the angle to ensure that we're going to go the correct direction. I'm sure this is confusing, but that's really the best way that I can explain it. I'm not a math professor, and I don't want to get too much into it because I'm sure I'll butcher the mathematical explanations of all the angles. Anyways, there we go. Okay, so that's kind of the first thing that we need to do. Now that we have that, though, we're going to say the difference in angles is, or just angle actually, is equal to self.angle minus, and then the desired radian angle. Now we need to first convert this to degrees. So we're going to say math.degrees like this. Okay, so remember, this is going to give us the angle in radians. So then we convert it to degrees, and then we take whatever our current angle is and subtract it by whatever the desired angle is to get to. And then based on if this number is positive or negative, we're going to know if we have to move left or right. Now, another problem happens here. What if the difference in these angles is really massive? What if it's 270 degrees? What if it's 290 degrees? In fact, what if it's anything larger than 180 degrees? Well, if the difference in the angle is larger than 180 degrees, we are going to be taking an inefficient route to get to the angle. So let me show you what I mean. If I go to Paint here and we zoom in, so let's go, come on, zoom in. Control plus, does that not zoom? Okay, let's just move this. Okay, so let's say we have this example here, right? Where we have some angle here, and actually let's just do one here. And then we have another angle here. Now, if we calculate the distance between this angle, or the difference between these angles, maybe we get something like 220 degrees, okay? That's fine. But if we were to go in this direction to get to this angle, we need to travel 220 degrees. Whereas if we go in this direction to get to this angle, then we have to only go 140 degrees. Is 140 degrees correct? Yeah, 360, yeah, 140. I think that's right. Okay, so we only have to go 140 degrees. So obviously we would prefer to go 140 degrees than to go 220. So what are we going to do if we have an angle that's greater than 180 degrees? Well, if we have an angle greater than 180, we know we're taking an inefficient route. So all we'll do is we'll take this angle and we'll subtract, so let's say it's 220, we'll subtract 360 from it. Now you might be saying, well, why don't you do the other way? The reason I'm not doing it the other way is because I want to actually get the negative angle by going backwards. So if I have 220 by minus 360, then what I'm going to get here is negative 140, which is what I want, because I don't want to go 140 degrees this way. I want to go the other direction 140 degrees. So that is how I'm going to kind of fix this problem of potentially turning the wrong direction, is I'm going to simplify this, or I'm going to do this check to make sure we're going in the right direction. Okay, so anyways, we have the difference in angle, and now we're going to say if the difference in angle is greater than or equal to 180 degrees, then we're just going to say the difference in angle minus equals 360. So now we'll turn the opposite direction. So now that we have calculated the difference in the angles, we don't even care what the difference is. Well, we actually will use it in a second, but we just want to move in the right direction now to get towards the angle that we want. So we're going to say if the difference in angle is greater than 0. So if the difference in angle is greater than 0, notice we're having our angle first and then the angle that we want to get to. We want to go the other way. We need to go to, I guess, the right as opposed to the left. And the reason for that is when we go to the left, we increase our angle. If our angle is already greater than the angle that we desire, we need to go the opposite direction to get to that angle. So we're going to say self dot and then angle is going to be minus equals, and this is going to be the, actually, let me check here, the minimum of self dot rotation velocity, and then the absolute value of the difference in the angle. Let me check that that's all good. Okay, yeah, that's what we want. So the reason for this is that I don't want to potentially pass the angle going the other direction. So let's say the difference in the angle is 3 degrees, and my rotational velocity is 4 degrees. If I just straight up go 4 degrees to the right, I'm going to pass by the angle that I want. And then what's going to happen is I'm going to pass by it, and now all of a sudden I'm going to be 1 degree less than the angle that I want. And so I'm going to have to move back the other way. But I can only move by my rotational velocity, so I'm going to move back by that. So what's going to happen is you're going to be like stuttering back and forth, like left, right, which you don't want. You want to just be, steadily on the angle. So the point of this kind of min right here is that if the difference in the angle is less than the rotational velocity, we'll move by that amount. So we snap precisely on the angle. We aren't going like above the angle, below the angle, above the angle, below the angle. That's the point. Okay, so now that we have this, we're just going to say else, because if it's not greater than 0, then it must be less than or equal to 0. And here, we're just going to swap this to a plus. Now, I think we can just leave the exact same thing in here. Yeah, we can. And that should actually be good. That will actually rotate our car so that it's going to move towards the point. So that is kind of the trickiest part right there. This very complicated method, I'm sure this doesn't make 100% sense. It doesn't have to. If I'm being honest with you, I don't understand it 100%. This was a lot of trial and error to get this to work. But hopefully what I explained gives you some sense of why we're doing the things that we're doing. Angles are difficult. That's the moral of the story and of this tutorial series. Okay, continuing. Now that we have that, what I would like to do is I would like to make sure that we move to the next point in our path when we are ready to do that. So I'm going to say define update underscore path point like that. And then inside of here, all I'm going to do is check for collision with the points that we have. So whatever point I'm currently on, I'm going to see if my car has collided with it. And if it has collided with it, then I've hit that point. We can go on to the next one. So let me just look at my cheat sheet right here. Okay, that looks good. I'm going to say the target is equal to, and this is going to be self.path at self.current point. I'm then going to create a rectangle from my car. Yeah, that's what we're going to do. We're going to say rect is equal to pygame dot, and then this is going to be, I guess it's just rect. Yeah, I think it is just rect, pygame.rect. And then we're going to, instead of doing target, going to say self.x, self.y, and then we need to get the width and the height of our image. So I'm going to say self.img.get_width and self.img.get_height. So the point of creating this rectangle is that my image alone is a rectangle, but it doesn't know its location, right? Like the image doesn't know where it is. So I make a rectangle using the X and the Y of my car as the top left-hand corner, and then I get the width and the height of my image. So now what I can do is use a built-in method in Python, in pygame, to determine if a point is colliding with my rectangle. Now this is pretty intuitive, but it is collide point like this. And all it does is take a point. So you have to call this on a rectangle, but it takes a point, which will be target, and tells you if you are colliding with it. Now, in fact, it actually takes a X and Y coordinate. So what I'm going to do is pass asterisk target, which will then pass the X coordinate and the Y coordinate as separate arguments to this function. If that's the case, if I am colliding with that point, I'm going to say self.currentPoint plus equals 1. So if we've hit the current point that we're going to, then let's move to the next point. That's the idea behind update path point. Now let me just look and see if I've messed anything up. Everything looks good to me. What we can actually do now is we can start running the car, like moving the car around, and you will see that it will start moving on the path. So let's see how to do that. Again, I have to reference my code here. Okay, it was easier than I thought. We're just going to say computer_car.move. Okay, so just like we have move player, now we have the move car. So let's do that. Let's run our code after we move our car. Let's cross our fingers and let's pray this works. And notice our car is zipping around the screen here and it's actually following these points. Okay. Now you will notice that sometimes it might kind of hit the edge, right? So you just saw right there, it almost hit the edge of the screen. Keep in mind that it is aiming to get its top left-hand corner on all of these points. So that's why it's taking these kind of wide turns. You'll notice that the top left-hand corner of the car is what's kind of aiming to intersect with some of these points. Okay, so we just ran into a problem there with this point right here. So that is most likely due to the fact that that point was too close to this one right here. And so we couldn't actually hit this point. We couldn't intersect this point from this one because we couldn't turn quickly enough. So what I'm going to do is kind of fix up some of these points and then I'll be right back. Notice we're getting another problem here. So in fact, let me just look at this and see maybe where I made a mistake and I'll be right back. So the problem is what I expected. The points that I have are just too close together so the car can't actually hit it. Now that will be fixed by lowering the velocity of the car because it can turn quicker than it can move. But to fix this, we just have to remake the path. So I'm just going to remake the path. I'll be right back. I'll show you the new path and then hopefully we should just be all good. All right, so I've just recreated the path here. Now I'm not going to lie, it's not perfect. It goes off the screen a few times, not very badly, but anyways, point being, I recreated the path. You guys know how to make the path. I showed you the code to do that. It's pretty straightforward. So you can mess with it and design as many times as you need to. Now, based on the way we have it right now, if you just clear the path at the start and then you add values to the path, the car will actually follow up until the last value in the path. That's the way that we've designed it. So every time I was clicking, it was actually going to that point, which was kind of cool. You could see how it kind of traced the path in real time. Now, one of the big reasons why it's hard for the car to actually hit some of the points is because of the turning radius, right? If you increase the rotational velocity, then you won't have the same problem that I'm having here. Just because it needs to take kind of a wide turn to be able to get to some of the points. Now that's going to change with speed, so you have to be careful. If you have a lower speed than your rotational velocity, it's not necessarily higher, but you can just turn more because you're not moving as quickly to each point. Anyways, I just wanted to point that out. Okay, so now I have this new path. So I'm just going to copy that into this path variable here. So let's get rid of all that. Let's paste that. And now let's repass path. Where is it? Right here. So I'll just show you what I had was I just added this code back in and that's how I was able to recreate the path. And then I had just cleared the path previously, okay? All right, so now that we have all of that, our computer is going against the player. So what I want to do now is get rid of the drawing of the path. So I'm just going to go and comment out under draw this self.drawPoints because I don't want to do that anymore. And I want to implement some collision between the computer and the finish line, just so I know if the computer gets to the finish line first. And then in the next video, we'll implement all of the level stuff, but this will just be kind of a nice thing to finish off right now. Okay, so just like we have this, the finish POI collide, I want to go player underscore, and I just want to preface this all with player because I'm going to do the exact same thing now, except with the computer. Although with the computer, I know it's not going to hit the finish line in the wrong direction, so all I have to do is just see if it hit the finish line, and then I know it crossed in the right direction. So I'm going to copy this, and I'll put it actually above here, and we can go like this. And instead of player, we'll just say computer. And then we will just change the player to be computer car. And now this will tell us if the computer has hit the finish line. So I can just do an if statement here, and I can say if the computer car computer underscore finish underscore POI underscore collide does not equal none, and then I can print out computer wins, exclamation point, because in this case, the computer would have gotten there before the player. Now, we do need to reset both the player and the computer if the computer does win. So I'm going to say player car.reset and computer car.reset. And that reminds me, inside of here, I also need to say computer car.reset because now if the player gets to the finish line, we need to reset the computer as well. Okay, we can get rid of the print statement. I'm not going to test this because I'm just very confident this is going to work. But what I'm going to do now is take all of this collision code and I'm just going to put it in a function. Again, just to kind of clean things up. So I'm going to say define handle underscore collision. Now we want to take both the computer car and the player car. So I'm going to say player car and computer car like that. Now inside of here, we'll do all of this and then we can just call that function. So I'll say handle collision, and then we'll pass the player car and the computer car, and let's just run this here and let's test and see. Yep, okay, I can hit the walls just like I was before. Great, so there we go. That is all working. And with that, that's going to end this video. So we're getting very close to finished here. We just haven't implemented the logic for the game and the nice text. So in the next video, we'll do all of that. But this is the hard stuff. What we're doing going forward is very simple. We just need to keep track of what level we're on. We just need to reset the cars in, the correct way. And yeah, all that stuff's pretty easy. So we'll wrap that up in the next video. If you enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in another one. Hello everybody and welcome to video 4 in this Pygame tutorial series. In this video, I'm going to be adding the finishing touches to this game, making it a fully functioning game. We have now implemented all of the physics and the logic to allow the players to move, but we need something that tells us if we won, if we lost, what level we're on, all of that kind of stuff. So that is what we will do now. Before I go any further though, if you have made it this far, give yourself a pat on the back and go leave a comment. Let me know what you've thought of this series so far. Any feedback, positive or negative, is more than appreciated. All right, let's continue and let's get into this. So we need to know levels. That is kind of the first thing we need here. The reason we need levels is because the computer is going to start off very slow and then it's going to get faster and faster, and it's going to determine its speed by the level. So what I'm going to do is make a class here. And we're going to call this class game info. Now, this is going to be responsible for exactly what it says, the information about the game. You're going to see why it's beneficial to do it in this way, but rather than creating like 20 variables to keep track of all of the stuff that we want, we'll just do it in this class, and then it makes our code very, very readable. So I'm just going to say levels is equal to 10. So it'll be a constant. We're going to have 10 levels in this game. If you wanted more, well, then you can increment this. Then I'm going to say define init underscore underscore, and I'm going to say self, and then level is equal to 1. This is just indicating that we're starting at level 1. Okay, then we're going to say self.level is equal to level. We're going to say self.started is equal to false, indicating whether or not the current level has started. And we're going to say self.level underscore start underscore time is equal to none. The reason that we're doing this is, actually we'll do it at 0, is because we want to know how much time has elapsed in the current level. That's something that we're going to do in here. Okay, so now we're going to say define, and we're going to implement some methods. We're going to say define next level. Now what this is going to do is say self.level and then plus equals 1. And then it's going to say self.started is equal to false, because if we're going to the next level, then we don't want to start the next level yet. We need to wait for the user to do that. Then we're going to say define, and this is going to be reset. Now inside of reset, we're just going to reset everything. So we're going to say self.level is equal to 1. We're going to say self.started is equal to false, and then self.level start time is equal to 0 as well. I think that's all we need to do. Then we're going to say define game underscore finished. We have to spell finished correctly. This will take in self, and this will simply return self.level is greater than self.levels. So if the current level is greater than however many levels we have, then we have finished the game. And then we'll say define, and this is going to be start underscore level. Now all this is going to do is it's going to say self.started equals true. And it's going to say self.level start time is equal to time.time. So that's why we imported time previously here. I'll go back to this so that you can read it. But the idea is we want to keep track of when the level started, and then we can easily determine how much time has elapsed by checking the current time and subtracting it from this. Okay, and then lastly, we're going to say define get underscore level underscore time self. And here we're just going to say if not self.started, then return 0. So if you haven't started the level, then no time has elapsed. Otherwise, we will return self.level start time minus time.time. Okay, I went through that relatively quickly, but that is the game info class. You can almost see all of it right there. Pretty straightforward, pretty simple, but it's just going to make our life easier as we go through this. Okay, so now that we have that, what I want to do is kind of make something pop up on the screen when we first start the game that says like press any key to begin level, right? So every time a new level happens, I want to say like press any key on the keyboard to start the level. That's all I want to do. So the way I'm going to do that is I'm going to go right after my draw here. I'm actually going to put another while loop. Now this while loop is going to wait until the level starts. And once the level starts, it will get out of it and then allow all of this stuff to happen. So you won't be able to move the car. The computer won't move until we start the level. So let me just go down here so I have a reference on my other screen. And this is what we're going to do. While not, and then this is going to be game underscore info dot started. Now we need to define game info. So I'm going to say game underscore info is equal to game info like that. And while not game info dot started, so I've not started the current level, we are going to blitz some text onto the screen. So I'm going to say when. Actually, I'm going to do something else, which I'm going to describe now. So what I want to do is write a function that is capable of writing any text onto the screen directly in the center of the screen. This is a very useful function to have. So to do this, we first need to define what's known as a font. So if you want to write text onto the screen in Pygame, you need a font. So what you're going to do is at the top of your program, you need to make sure you do this at the very top. You're going to say pygame.font.init, obviously after you import Pygame. Then what I'm going to do is I'm going to actually define a font object. This font object is what you can then use to render text with that font. So I'm going to say main underscore font is equal to pygame.font.sys font, not system font, just sys font. And then inside of here, there's a bunch of options, but you guys know that I always go with Comic Sans. And then you can put the size, and for now I'm going to go with 44. Now this is the text size. Change this obviously to whatever you want. 44 is a good size though for like some title text, which is what we're going to have. Okay, so now we have our font. This will only work if you initialize the font. So if you're having an issue, just make sure you init the font first. And now that we have the font, we can use that to render some text. So I'm going to go in utils.py. I'm going to make a new function. I'm going to say define, and then this is going to be blit underscore text underscore center. And this is going to take in a window. It's going to take in a font, and it's going to take in some text. All right, so inside of here, I'm going to say render is equal to font.render. And then we're going to put the text that we want to render, the anti-aliasing, which is 1. And then we're going to put the color, which is going to be white. So 255, 255, 255. And in fact, let's make it let's go with like 200, 200, 200, just so it's gray because we have white on the screen already. Actually, is this going to give me white? I'm not sure what this color is going to be. You know what? We'll experiment with 200, 200, 200, and we'll see what that gives us. In case you're curious, you just put text you want to render. You put anti-aliasing. Just always put 1 for this. I won't really explain it. Just you always want 1 here. And then you're going to put the color. And then you can actually blit this text onto the screen just like an image. Say win.blit, render. And then we need to put the position we want to render this at. The top left-hand corner, by the way, that's where you're putting here. So what I want to do is I want to render this at the win.get_width. Why did it fill all of that in? Okay, that's fine. Divided by 2. And then this is going to be subtracted by, and this is going to be the render.get_width over 2. So what this is doing is, let's go to Paint, and I will show you. So let's say we have our window, okay? We obviously have some width, and we have some height. And then we have the text that we want to render. And I want my text to be here. Now I need to calculate this position. Not this. This would be easy enough. I just take width over 2. I want this. So the way you do it is the following. This is width over 2, right? W over 2. So you subtract from this half of the text width. Pretty straightforward, but if you just subtract half of the text width from half of the screen width, you get the top left-hand corner position of where the text should be drawn from so that it's going to fill the entire screen and be directly in the center like that. Now you can just do the exact same thing in the height, and well, that will give you the coordinate for Y that you want this to be at, right? So it would give you it, around here. Okay. Actually, it would be probably close to around where I have it right now. Hopefully that makes sense, but that's my quick Paint explanation. And let's go here, win.get_height over 2 minus render.get_height over 2. Okay, so it filled that in for me. That is great. So that's going to render my text on the screen in the middle. We're going to use that a few times. That's why I wrote that. Now we want to import that. So from utils, import blit text center. And then we're going to go down to our, where were we? Our while loop inside of here, and we are going to render this. So we are going to say blit text center like that. And we're going to make an F string, only available in Python version 3.6 and above, by the way. I'm going to say press any key to start level. And then inside of here, I'm going to say game info.level exclamation point. Okay. Now that's the text. That's actually the last thing that we're going to pass. The first thing is win. The second thing is our font, which is main font, and then our text. If you're unfamiliar with F strings, the way they work is you can embed expressions directly inside of curly braces. You just put a lowercase or uppercase F before the string. So now whatever the level is, we'll say press any key to start level 1, 2, 3, so on and so forth. Okay, now win needs to be capital. Forgot about that. And now that we have blit that text onto the screen, what I'm going to do is do an event loop. I'm going to say for event in pygame.event.get. I'm going to actually copy this. It seems inefficient to rewrite this, but it's simpler than trying to come up with a cleaner way, essentially. And I'm going to still have this kind of quit clause, except instead of run equals false, I'm just going to say pygame.quit. Okay. And then here, I'm going to say if event.type equals pygame.key down. This means you pressed any key down. Then what I'm going to do is say game info dot start level. So we're going to call that start level method that will start the current level, which means this while loop will now exit, and then we will go on and, well, we will have the level. Now I'm wondering if I'm missing anything. I am. The one thing I'm missing is I need to manually update this display here. So pygame.display.update to ensure I actually show this, because we're going to be skipping this draw function. Hopefully that kind of makes sense, but we're drawing everything, right? And then we have this while loop, and this is only going to run if we haven't started the current level. So if we haven't started the current level, we put this text over top of everything in the middle of the screen, and then as soon as they press the key down, we're going to exit out of this while loop and then start the game, and the current level will start. And then if I go here, let's just make sure start level looks good inside of this class. Okay, all good. So let's run the code and see what we get. Okay, notice it says press any key to start level 1. Maybe we want to move it up a tiny bit because it's kind of hard to read when it's over top of the white, but for me, that's fine. Press any key and then notice the car starts going and we can start moving. All right, there you go. So that is how we start the current level. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. They have over 160 coding interview practice questions, mock interviews, a data structures crash course, all kinds of other great features. Of course, I am an instructor on the platform, so you know there's going to be some quality content. And well, with that said, you can check them out from the link in the description and use the code TechWithTim for a discount on the platform. Now that we have that, I just want some text in the bottom left-hand corner displaying the current level, displaying your current velocity, and displaying the amount of time elapsed in the level, which is actually pretty easy to do. So inside of the draw function, now what I'm going to do is also take in my game info. So now I'm going to go inside of draw and I'm going to start rendering some text and drawing some stats onto the screen. So let me go to my code here just so that this will be a bit faster for me to code out. And I'm going to start by saying that my level text, let's go like this, level underscore text is equal to, and then this is going to be main font dot render. And I want this to say level and then game info dot level like that. And then I want the anti-aliasing 1 and the color of white, 255, 255, 255. Okay, now I'm going to render my level text. So I'm going to say, not render, so I'm going to display it on the screen, win.blit level text. And then where do I want this? I'm just going to tell you the position, but you can feel free to mess with it all you want. I'm going to say 10, and then I'm going to say height minus, and this is going to be level text dot get underscore height minus 70. This is because we're going to put 2 other things below this. Now, the reason I'm doing this is so that it's dynamic. So if I ever decide to change the height of my screen, then I don't need to change this right here because it's based on the height of the screen, which is height, and the height of whatever this text is here. So again, if I change the height or the size of the text, I won't need to modify anything. This will just automatically adjust itself and put itself in the bottom left-hand corner. Okay, so I'm just going to copy this now because we're going to do the same thing for velocity and time. So I'm going to say time text, and this will be time text like that. The minus here is going to be 40. Because we're going to have 30 pixels offset. That is something that we manually would have to update, but that's fine. And then here I'm going to say time colon, and this is going to be equal to game info dot get level time like that. Okay, that looks good to me. Now let's copy this, and we're going to do the same now with our player velocity, just so we can see how quick it's going. I just figured that would be a cool stat to add. So now we're going to say vel, and then this. Actually, let's add a second here too. Let's add an S just so it says seconds. But for velocity, I'm going to go with, this is going to be player car dot velocity. And then we'll go with px per second, standing for pixels per second, just so we have some unit there. We'll go with white again. Now, instead of time text, this is going to be called vel text. So we'll just change these all to be vel. So this is going to be vel. And then rather than minus 40, we're going to go minus 10. So 70, 40, 10. The pattern is 30 less every time. All right, there we go. That's it for drawing that text on the screen. Now let's run the code and let's see what we get. Draw takes 4 positional arguments, but 5 were given. Good call. I forgot to import my game info or to add this as a parameter. So do that, and now we should be good. Remember, I passed game info into the draw function here. Okay, let's run the code. And notice that now we get level 1, time 0 seconds, velocity 0 pixels. And when I start this, now notice we have our time. Now, that's kind of ugly, and it's negative, which means I messed something up. So we're going to have to fix that in a second. But then you can see the velocity gets updated here as well. Great, so that's fine. But what I want to do is I want to round, first of all, the velocity. So let's do that. Let's go to my velocity. And let's just round this to 1 significant digit. So round and then comma 1. And then let's go to our game info class here. And let's see where I messed up. So I did self.level start time minus time.time. The reason this is incorrect is because time.time is going to be after the start time. So I need to flip this around and say time.time minus that. And then I will as well round this but I'm just going to round this to 0 places. So just do a whole number because this is going to give me the displacement in seconds, or the difference in seconds. Okay. So let's run this now and let's see what we get. And now notice that the velocity is all good, and so is the time. Perfect. There you go. Okay, so that's all we need for those stats. Okay, so now that we have that, we have the velocity, we have the time, we have the level showing up, what I need to do is make it so that my computer gets faster every time I beat a level. So what we need to do is go inside of our computer car here, and we need to write a method that's going to allow it to update its speed based on the current level. So I'm just going to say define next underscore level. And what we will do is say self. Now, when we go to the next level, what we need to do is reset this car. Now, we could manually call reset outside, but the first thing we'll do is say self.reset. Like that, so that this is going to go to its start position, its velocity is going to get updated, all of that. However, after we reset the car, we then need to change its velocity based on the level. So I'm just going to say level inside of here. So we're going to reset the car. And we're going to say self.vel is equal to, and then we'll go with whatever the self.maxvel is that was passed, plus, and then this is going to be level minus 1 multiplied by 0.2. Now 0.2 is how much I want to increase the speed of this car every level. We could put this in a variable. I'm just going to hard code it in for right now. You also could change this and make it something like 0.5. The one thing to keep in mind is you do not want this car to ever be faster than the player car. If it's faster than the player car, there's no way the player will win. It's just impossible because this car will take, assuming you did a good path, the best possible line around the track. And so there's no way the human's going to be able to beat it, especially because it doesn't have to worry about acceleration. It just starts at the maximum speed. So you need to make sure that whatever your increment here is, that multiplied by the number of levels that you have plus the maximum velocity you start with is not greater than the player's speed. You could make it the same, but even if you make it the same, then the player still can't win. So this is fine. I'm saying level minus 1, which means on the very last level, I will have 9 multiplied by 0.2, so 1.8. So the speed will be 3.8, so it'll be 0.2 slower than the player. Hopefully that is good. Let me just make sure that that all makes sense. Yes. And then the last thing we need to do is say self.currentPoint is equal to 0, although that should really go inside of the reset method. So where is reset? Reset was in the abstract class. Okay, so we can leave self.currentPoint here. All right, that should be good. Now we just need to see where we should call next level. So what I'm going to do now is go to my handle collision. Handle collision now needs to take game info as well. And so when we call handle collision, we need to pass game info. And now we're going to start kind of working on what happens when the computer wins or when the player wins. So if the computer finishes, we are going to reset the player car, reset the computer car. That looks fine. Okay, and now we go here to when the player finishes. Well, if the player finishes, then rather than computer car.reset, we're just going to say computer car.nextLevel, and we're going to pass game info.level. But first, we're going to say game info dot and then next level like that. So we're going to increment the next level for game info if the player has won. We're going to reset the player car, and then this will reset the computer car and change its speed for the next level. So that should be good. Now, by doing this, it means that this will automatically trigger for the next level because the game will now not have been started. We'll be waiting for the next level to be started. Okay, that's fine. The only thing we need to handle now is if the computer wins. So if the computer wins, we need to put some message on the screen saying, hey, you lost, whatever, and then we need to reset the game. So we'll actually go game info.reset. And before we do that, let's just put some text on the screen. So let's say blit text center. And then this is going to be, what do we want to say here? You lost, exclamation point. And we'll do this on the window and we'll pass the main font. Okay. Then we need to manually, this is going to be capital win like that. We need to manually delay the game. The reason we need to delay is so that we have time to see this text, because what's going to happen is we're going to show you lost. We're going to delay for however many seconds you want. I'm going to go with 5 seconds. And then as soon as that delay is done, it's going to automatically restart the game for us. So I'm going to say pygame dot time and then dot wait. And you put milliseconds in here. So 5,000 milliseconds is 5 seconds. So we're going to do that. Okay, that should be good. The only other thing we need to handle is what happens if the player wins the game, but we're going to do that here. So after we move the player and after we move the computer and after we handle the collision, then we're going to say if the game info dot game finished, we want to do a very similar thing to what we just did here. We want to reset all of this stuff. So we'll do that. And we want to blit text, you won the game. Like that. Okay, so that's actually all we need. Now I'm going to get rid of this print statement. And I believe that we have just finished the game. Now, obviously, I'm not that confident because we have not tested it right now. But scrolling through, everything looks good. And I think we've just handled everything that we needed to. And I'm also realizing how much code we have here. So again, a massive props to you guys if you stuck around because this is a lot of code to digest over video. All right, let's run the file. And let's see if we can win a level here. Okay, let's press any key to start. And never mind, I remember that the guy, my computer, did I start him at a speed of 2 or did I start him at a higher speed? Let's see what speed he's at. Yeah, it's at 4. Okay, so I need to put my computer car speed to 2. Otherwise, I'm going to have no chance here. Okay, so let's run the code. And let's see. That's better. Okay. So now let's try to get a win here. And we'll see if the levels are working. Okay, look at this driving skill. Nice, nice. All right, almost there. See if we can finish before the computer. I'm hoping so. And there we go. Okay, so level 2. And it says press any key to start level 2. Okay, so let's do level 2. Let's just make sure it goes to level 3. And then I will kind of fast forward as I get to the final level, and we'll make sure that this actually works if the computer wins and if I win. Okay, but let's just get through level 2 first, though, to ensure that we're going to get on to the next level. Okay, almost there. I forget what the time was on the last one. I should have kept track of that. Then I could have seen if we were going faster this time. Oops. Okay, looks like there's an invisible wall there. That's, I guess that's going to happen. And let's try to get up here. And okay, press any key to start. Level 3. We're on level 3. So now what I'm going to do is let the computer win. I'll fast forward through that. Assuming that works, then we'll see and make sure that the game actually ends when we hit level 10. All right, so here we go, home stretch of the computer. You can see I haven't really moved until now. Let's see what happens when the computer wins. And nothing. Okay, so that's actually a good thing to run into because, oh, it says press any key to start level 1. So I guess it lagged for a second. Okay, let's see what the problem was here. I'm guessing the problem has to... Okay, this makes sense. So what happened was we delayed for 5,000 seconds, or 5,000 milliseconds, so 5 seconds, but we forgot to update the display to actually show this message. So I have to say pygame.display.update, and now this will work. I'm not going to test it. I know that this will work now, and everything will be good because it did actually reset back to level 1. So with that, I believe everything should be working. I'm not actually going to go through and test the fact that the player wins works properly. I have faith that I've coded this correctly, especially because I have the finished code on my other side and these two pieces of code are identical. Although if for some reason it doesn't work, please do let me know. I'm sure the error is very easy to fix if there is one, although I doubt there is. All right, so with that said, I'm going to end the video here. I just quickly want to thank everyone who got through all of this. I hope that you learned something from this. I hope my explanations were decent enough for some of this complex code. It is difficult to do a video where, you know, you have about 300 lines of code. That's kind of what we ended up having here, right? Tons of code, lots of code in different files as well, all kinds of classes, all kinds of functions. We used a lot of different Python features. So again, hopefully you learned a lot and you enjoyed this video. If you did, make sure you leave a like, subscribe to the channel, let me know what you want to see for future content, and I hope to see you in the next YouTube video.